Welcome students. This particular course on calculus derivatives can be used by high school students, senior secondary school students, also by graduate students who are pursuing calculus 1 and calculus 2, and also by engineering students, both engineering at basic as well as at higher engineering. So having mentioned this, the objective of this particular course is to give you all the differentiation of the functions, so that you can use this as the ultimate derivative guide. So having mentioned this, let us move on. So the first differentiation that you will have to know is what would you do if you are given d over dx of some k, where k is a constant. Now you will have to know the outcome is always going to be 0. In other words, whenever we are talking about derivative, it means we are talking about a change. So the d over dx of any constant for that matter will always give you 0. In other words, a constant does not change. If you try to change it, the outcome is going to be a 0. So this is very similar to, say for example, you got $1,000 US. You are just keeping $1,000 US with your in your wallet. It's always going to be $1,000, and if you try to change it, right, what would happen? In other words, the inference that you will have to know here is this $1,000 US is not going to be producing anything if you are going to be simply housing it in your wallet, unless or until some change in terms of action takes place. Now for this action to be involved, you need to have a variable. So that is exactly what I wish to bring it to your attention. So having mentioned this, let us move on. Now what if you have, say, d over dx of some a times x positive b. Now over here a is a constant and b is a constant. So probably I can just simply state it like this: a and b are constant. Now in this case, whenever you're differentiating this is actually d over dx of a times x positive d over dx of b. Now we already know the b is a constant, so differentiation of a constant is going to be 0. But in this case, I've got a along with the variable. So in this case, when you're trying to differentiate this is actually a times d over dx of x, meaning you can always take the scalar out and differentiate the variable. Now if you had to differentiate x, since the differentiation is with reference to x, the outcome is going to be a times of 1 positive 0, which is going to be equal to a. So this is the solution. Now moving on, question number 3. Suppose you are given d over dx of a times x squared positive b times x positive c. Now this is nothing but, by linear property of derivatives, I can rewrite this as d over dx of a times x squared positive d over dx of bx positive d over dx of c. And this can be further rewritten as a times d over dx of x squared positive d over dx. In fact, b, I can place b out, and then this is x positive differentiation of a constant is going to give me 0. Now this is going to be a times, d over dx of x squared is actually 2 times x times differentiation of x, that's going to be 1. I don't have to place that 1 there, this is enough. Positive b times differentiation of x will give me 1, which can be rewritten as 2 times ax positive b. So this is the outcome. Now the most popular differentiation is, what would you do if in case you got d over dx of some x to the power n? Now this is the resultant that you will have to get, n times x raised to the power of n negative 1. So this is the most popular formula that you will have to know with when it comes to differentiation. So have this in mind. So having mentioned this, the meaning is, suppose you are given, say, d over dx of, say, x to the power of 7. The outcome is nothing but 7 times x raised to the power of 7 negative 1, which is nothing but 7 times x raised to the power of 6. So this is going to be the answer. So every effort has to be made to have this formula at the corner of your mind. So having mentioned this, we will move on to the next question. Now, this is a very important rule that you will have to know. This is called as the product rule. Now, suppose you are asked to differentiate u times v. Then the formula is u times v dash positive v times u dash. So remember this. This is popularly known as product rule. So I'm going to perform a differentiation for this. Now, before I could perform a differentiation for this, imagine that you are given a question like this. Say y is equal to, say, x squared times sine x, and you are asked to find dy over dx. Now, there are a few things you will have to know. So there is a composition of an algebraic function and a trigonometric function. Okay. Now, when it comes to trigonometric function, you will have to know the standard differentiations of the following trigonometric functions. That is, let me write that down. D over dx of sine x is equal to cos x. Okay. D over dx, let me just write it down like this. D over dx of cos x is equal to negative sine x. So to start off with, I'm just going to be giving you these two trigonometric functions. So later on, as we move on, I'm going to list on other trigonometric functions. So remember, differentiation of sine x is cos x, but differentiation of cos x is going to be negative sine x. So having mentioned this, let me just differentiate x squared and sine x. So whenever you want to differentiate this, it's better that you take one quantity as u and the other quantity as v, and then you find the differentiation. What is differentiation? So differentiation of u can also be written as du. It can also be represented as u dash. That is nothing but differentiation of x squared. Now you can either use this formula, which would result in 2 times x raised to the power of 2 negative 1, which is going to be equal to 2 times of x. So this is my u dash. And coming to my v dash. Now differentiation of v dash, I should say differentiation of v dash, it can be written as dv, or it can be represented as v dash. Now clearly I've given you differentiation of sine x is going to be cos x, so that's nothing but cos x. Now I'm expected to obtain dy over dx, right? So therefore my dy over dx is nothing but u times product rule, v dash positive v times u dash. So this is nothing but my u is x squared, my v dash is cos x, positive my v is sine x, and my u dash is 2 times x. So when you're writing this, you have to write it like this: x squared times cos x positive 2 times x of sine x. Now I have given you applying the formula, but if you are very, say for example, convenient, or I would say if you are familiarized with this application of the formula, then you don't have to worry about the methods that I've shown you, the step-by-step way of execution. You can directly say you take x squared times differentiation of sine x, which is cos x, positive differentiation of x squared as 2x, and you retain sine x. So that will be the solution. Now let's just try one more question, just for the sake of familiarity. So what if I ask you, if I give you y is equal to, say, x to the power of some 8, and you will have to obtain cos x. In fact, you will have to obtain the differentiation of x raised to the power of 8 times cos x. So I'm going to be using this formula. So let me just write the formula: d of u times v is equal to u times v dash positive v times u dash. So from this formula, if I were to take, if my u is x to the power of 8, my u dash is going to be 8 times x to the power of 8 negative 1, which is 8 times x to the power of 7, and my v is going to be cos x. Clearly differentiation of cos x will give me negative sine x. So therefore dy over dx is going to be what? U times v dash, positive v times u dash, which is equal to, my u is x to the power of 8, my v dash is sine x with a negative sign, positive, my v is cos x, and differentiation of u is nothing but 8 times x to the power of 7. So I can rewrite this as negative x to the power of 8 sine x, positive 8 times x to the power of 7 times cos x. This is my dy over dx. So this is my final solution. Now, as I mentioned to you, you don't have to stick to this entire process. Directly what you can do is retain x to the power of 8, then you differentiate cos x, that's negative sine x, write it down, positive. Now retain cos x and you differentiate x power 8, that's nothing but 8 times x to the power of 7. So this is going to be your solution. So that is our question number 8. Let's move on to question number 9. Okay students, now we are going to study what is called as the quotient rule. Now what exactly is the quotient rule? Now suppose you have a term like this. You are expected to differentiate u over v. Then the formula is going to be v times u dash minus u times v dash divided by v squared. I'm going to explain to you by means of an illustration. So over here I'm explaining to you what is called as the product rule. Now it's time for us to study quotient rule. Now suppose you are given a question, say y is equal to say some x squared divided by say sine x, and we are expected to find the dy over dx. Now first and foremost thing what you have to do is you have to take let u be equal to x squared and then probably v be equal to sine x. Then you find u dash, which is nothing but 2x, and find v dash, which is nothing but cos x. Then you apply the formula. What is the formula? The quotient rule is v times u dash minus u times v dash divided by v squared. So what is my v? My v is sine x. And what is my u dash? My u dash is 2x followed by a negative sign. What's my u? My u is x squared. What's my v dash? It's cos x divided by my v is going to be sine x. That has to be raised to the power of 2. So if you had to rewrite this, this is going to be 2 times x sine x negative x squared times cos x divided by sine x raised to the power of 2 is going to be sine squared x. Now what is this? This is my dy over dx. Okay, therefore my dy over dx is this. So quotient rule is a very important rule. Now I'm going to do another question. So question number 10, I'm going to say you are expected to find d over dx of sine x divided by 1 positive cos x. So what I'm going to do is I'm going to say let u be equal to sine x and v be equal to 1 positive cos x. So therefore d over, in fact I can just simply write it as d of u over v is equal to v times u dash minus u times v dash divided by v squared. So by this formula over here I can write u dash is equal to cos x. Over here v dash is equal to negative sine x. I can put this entire thing in a box. Dy over dx is going to be equal to, my v is 1 positive cos x and my u dash is cos x, negative my u is sine x and my v dash is negative sine x divided by v raised to the power of 2. That's going to be 1 positive cos x raised to the power of 2. This can be simplified as follows. So cos x into 1 is cos x plus cos squared x, negative negative positive, and that would give me sine squared x divided by 1 positive cos x raised to the power of 2. These two can be added. That is going to give me 1. So I can rewrite this 1 positive cos x divided by 1 positive cos x raised to the power of 2. So I can cancel 1 and write this as 1 over 1 positive cos x. So this will be my solution for dy over dx. Or probably you can, instead of writing d over dx, this is nothing but the differentiation of d over dx of sine x divided by 1 positive cos x. Okay, so either this or this. So this is the solution for this question. Students, question number 11, we are expected to differentiate 1 positive cos x divided by sin x. So as usual, what I'm going to do is I'm going to take, let u be equal to the numerator and my v to be equal to the denominator. My u dash, differentiation of 1 is 0, differentiation of cos x is negative sin x, and differentiation of sin x is going to give me cos x. So therefore, if I were to obtain my d of u over v, I can just simply write it like this. Differentiation d of u over v is nothing but v times u dash minus u times v dash divided by v squared. So hence, differentiation of d over dx of 1 positive cos x divided by sin x, this is equal to, my v is sin x, my u dash is negative sin x, negative, my u is 1 positive cos x, my v dash is cos x, divided by my v squared is going to be sin x raised to the power of 2. So if you were to simplify this, this is negative sin squared x, cos x into 1 negative cos x, and negative cos x into cos x will give me cos squared x, divided by my v is sin squared x. Now I get a negative sin squared x, negative cos squared x, so I can take a negative sign out. So this is going to give me sin squared x positive cos squared x followed by a negative cos x divided by sin squared x. Sin squared x cos squared x is going to be 1, so it's going to be negative 1 negative cos x divided by sin squared x. So this is going to be negative of 1 positive cos x divided by sin squared x. But sin squared x is 1 negative cos squared x. So I'm going to substitute that. It's going to be negative of 1 positive cos x divided by 1 negative cos squared x. 1 negative cos squared x. Now 1 negative cos squared x can be rewritten as 1 negative cos x multiplied with 1 positive cos x. So that would mean this is nothing but negative of 1 positive cos x divided by 1 negative cos x multiplied with 1 positive cos x. 1 positive cos x, 1 positive cos x gets cancelled, giving you negative 1 over 1 negative cos x. Now if you want, you can take the negative sign out. If you take the negative sign out, this will give you cos x negative 1. So it can be changed into positive. So you get 1 over cos x negative 1 to be the solution for this question. Students, we are expected to find the derivative of sin x over cos x. Now as usual, what I would do is I would take u to be equal to sin x and my v to be equal to cos x. So u dash is going to be equal to cos x and my v dash is going to be equal to negative sin x. So I'll be using the formula d of u over v is equal to v times u dash minus u times v dash divided by v squared. So by this formula, therefore d over dx of sin x divided by cos x can be rewritten as, my v is cos x, so that has to be followed with negative, my u is sin x and my v dash is negative sin x. So divided by my v is cos x, that has to be raised to the power of 2. Now cos x times cos x will give me cos squared x, negative is positive, sin x times sin x gives me sin squared x, divided by cos x raised to the power of 2 is cos squared x. Now cos squared x plus sin squared x is 1, so I'm having 1 over cos squared x. Now you'll have to know one thing. Now secant x has a representation as 1 over cos x. Now cosecant x has a representation as 1 over sin x. Tan x has a representation as sin x divided by cos x, and cot x as a representation as cos x over sin x. So these are all some of the representation that you will have to know. So from here, secant squared x. So therefore, if I were to differentiate d over dx of sin x divided by cos x, which is actually d over dx of sin x over cos x is tan x, then differential of tan x is nothing but secant squared x. So have this in mind. So this is a very important formula that you will have to remember. Differentiation of tan x is secant squared x. So this is question number 12. So let us move on to question number 13. So what if instead of giving d over dx of sin x over cos x, they were to give you cos x over sin x? What would you do? So as usual, let u be equal to cos x and my v be equal to sin x. My u dash is negative sin x. My v dash is cos x. So therefore, d of u over v is nothing but v times u dash minus u times v dash divided by v squared. So this is going to be my v is sin x, my u dash is negative sin x, negative my u is cos x, and my v dash is cos x. This divided by my v is sin x raised to the power of 2. This is equal to, let me just write this down. Therefore, d over dx of cos x divided by sin x is equal to sin x into sin x is sin squared x, negative sign is there, place that, cos x into cos x is cos squared x, place that, divided by sin x raised to the power of 2 will give me sin squared x. I can take a negative sign out and then rewrite this as sin squared x positive cos squared x divided by sin squared x. Sin squared x positive cos squared x is 1. There's a negative sign there, place a negative sign, divided by sin squared x. Now what is 1 over sin squared x? 1 over sin x is cosecant x. So therefore 1 over sin squared x is going to be cosecant squared x. But there's a negative sign here, so place a negative sign here. So hence we have arrived at a new differentiation. Hence d over dx of cos x over sin x, this is actually d over dx of cot x. So when you differentiate cot x, what do you get? You get negative cosecant squared x. So this is a very important formula that you will have to remember. Differential of cot x is negative cosecant squared x, but differential of tan x is secant squared x. So there are two variations that you will have to remember, and these two are very important in calculus, both 1 and 2. Now we have asked to obtain the differentiation of 1 over sin x. So as usual, what I'm going to do, I'm going to take u to be as 1 and my v to be as sin x. Differentiation of this constant will give me 0. Differentiation of sin x will give me cos x. So I'm going to use this formula. Therefore d of u over v is nothing but v times u dash minus u times v dash divided by v squared. So if I were to use this formula, my v is sin x times my u dash is 0 followed by a negative, my u is 1, my v dash is cos x. So I can write that down, divided by my v is sin x raised to the power of 2. So if you were to rewrite this, this is going to be 0, but I got a negative 1 multiplied by cos x, so I'm going to write that down, divided by sin x raised to the power of 2, I'm going to write it as sin squared x. Now I can rewrite this as negative cos x divided by sin x times 1 over sin x, which is nothing but, now cos x over sin x, what is that? That is nothing but cot x. Now 1 over sin x, what is that? Cosecant x. Now I can rewrite this as negative cosecant x times cot x. What is this? This is nothing but d over dx of 1 over sin x. But what is 1 over sin x? 1 over sin x is nothing but cosecant x. So this is a very important differentiation. What is that? When you differentiate cosecant x, you get negative cosecant x cot x. So have that in mind. Now moving on, question number 15. What if they ask you d over dx of 1 over cos x? right? That is also a possibility, right? They can ask a question like that. So what would you do? As usual, I'm going to take u is equal to 1 and my v is equal to cos x. So from here, u dash is equal to 0 and my v dash is equal to negative sin x. So therefore, d of u over v is nothing but v times u dash minus u times v dash divided by v squared. So this is nothing but my v is cos x, differentiation of u which is 0, negative u is 1, differentiation of v dash, differentiation of v in fact, that's going to be negative sin x divided by v squared. My v is cos x, so I need to raise it to the power of 2. Negative, negative, positive. So this is going to be sin x divided by cos x raised to the power of 2 will give me cos squared x. Now I can rewrite this as sin x divided by cos x times 1 over cos x. But what is sin x over cos x? Tan x. What is 1 over cos x? Secant x. So I can rewrite this as secant x times tan x. So therefore what we have got? So therefore d over dx of 1 over cos x, which is nothing but d over dx, 1 over cos x is nothing but secant x, right? So we got a very important differentiation. What is the differentiation? Differentiating secant x will give us secant x times tan x. So I'm going to box this so that you will remember this result. Now having obtained this, let us move on to the next question. Now what if they give you differentiation of root of x? This is very important. How do you do this? Now it is imperative to know that if I have a square root of x, I can always write this as x raised to the power of 1 over 2, right? Now I'm going to use this formula. We know that d over dx of x raised to the power of n is equal to n times x raised to the power of n negative 1. Now by this formula, this is going to be 1 over 2 times x raised to the power of 1 over 2 negative 1, which can be rewritten as 1 over 2 times x raised to the power of half negative 1 will give me negative half. I can rewrite this as 1 over 2 times. I can push this down. So this is going to be x over positive 1 over 2, which can be rewritten as 1 over 2 times root of x. So have this in mind. So therefore what have we got? We got d over dx of root of x is equal to 1 over 2 times root of x. So this is a very important formula that you will have to know. Now sometimes what they will give is, they will give, find out the differentiation of root of say 3 times x positive some 4. How would you do this? You cannot simply consider this as this and perform the differentiation. You can't do that. So you will have to have a strategy. I'm going to show you the strategy now. Now I'm going to show you long way and short way. So let's get started. Now this can be rewritten as d over dx of 3x positive 4 raised to the power of 1 over 2. Now if you were to differentiate, this is going to be 1 over 2 times 3x positive 4 raised to the power of 1 over 2 negative 1 times you will have to differentiate 3x positive 4. This is what you have to do, right? 3x positive 4 is a quantity inside the square root. So this should immediately follow. Now I can rewrite this as 1 over 2 times 3x positive 4. This is negative 1 over 2 times differentiation of 3x will give me 3. Differentiation of 4 is going to be 0. So this is rewritten as 3. Now this can be pushed down. So it's going to be 2 times. When you push down, this is going to be 3x positive 4 raised to the power of positive half. So I can simply write this as 3x positive 4. So this is the solution. Now, if you don't want to do all of this, just take note of this. What is this? This is nothing but 1 over 2 times root of x, right? So the short way, if you get something like this and you are asked to obtain the differentiation of say root of 3x positive 4, what you got to do is simply write this 1 over 2 times root of 3x positive 4, and after that just differentiate this quantity. So what is the differentiation of 3x? It's going to be 3. Differentiation of 4 is 0. So the solution is going to be 3 over 2 times root of 3x positive 4. So that would be the final answer that you will have to do. So either you can follow this or you can follow this, depending upon your convenience. So that is the solution for question number 16. Students, we are expected to differentiate sine cubed x. So what we have to do is we will have to start by getting it like this: 3 times sine raised to the power of 3 negative 1 times x times differentiation of sine x. So this can be rewritten as 3 times sine 3 negative 2 will give me 3 negative 1 will give me 2 times x. Differentiation of sine x is going to be cos x. So this should be your final answer. Now instead of like this, if they were to give you like this, a d over dx of sine of x cubed. Okay, so this is nothing but differentiation of this entire quantity. That is nothing but cos of x cubed, right? Times you differentiate x to the power of 3. So that is going to give you cos of x cubed times differentiation of x cubed is going to be 3x squared. So this can be rewritten as 3x squared times cos of x cubed. So this should be your solution. Now they can simultaneously mix up these things. Suppose you are asked to obtain the differentiation of some terms like this: d over dx of, say, cos cubed of x positive cos of x to the power of 4. So what would you do? First and foremost thing, you will have to rewrite it like this: d over dx of cos cubed x positive d over dx of cos of x to the power of 4. Right? It doesn't matter, you don't have to place a parenthesis, but just for the sake of identification I am placing it. So differential of cos cubed x, that is going to be negative. First we have to bring the 3 down. So it's going to be 3 times of cos raised to the power of 3 negative 1 times dx times differentiation of cos x. Positive, in this case the entire differentiation, that's going to be negative sine of x to the power of 4 times differentiation of x to the power of 4. So this can be rewritten as 3 times cos raised to the power of 2x. Differentiation of cos x is going to give me negative sine x. This is going to be giving me negative sine of x to the power of 4 times differentiation of x to the power of 4 is going to be 4x to the power of 3. So if you were to rewrite this, this is going to be, of course, 3 times cos squared x times sine x negative 4 times x to the power of 3 times sine x to the power of 4. So this should be your solution for this question. Now question number 20, let us imagine that you've been given this. Say d over dx of 1 over x raised to the power of some 9. So what would your differentiation be? Now foremost, to differentiate this, what we have to do is we will have to rewrite this first. Rewriting means first you take it to the numerator. So x power 9, which is in the denominator, when it goes to the numerator, this will become x raised to the power of negative 9. Then we know this formula. So what is the formula we know? D of x to the power of n is nothing but n times x to the power of n negative 1. So by using this formula, I can rewrite this as negative 9 times x raised to the power of negative 9 negative 1, which is negative 9 times x raised to the power of negative 10, which can be rewritten as negative 9 over, I can push this x raised to the power of negative 10 down. In that case, it will become x raised to the power of positive 10. So this will be the solution. Now what we can do is, we can also have another variation. What if they ask you d over dx of 1 over root of x? Already we studied this. If you remember, I've already shown you what happens to the differentiation of root of x. So in this case, we got root of x in the denominator. So for that, first and foremost thing that you should do is rewrite this as 1 over x raised to the power of half. Then you take that to the numerator, x raised to the power of negative half. Then you differentiate this. This is nothing but negative 1 over 2 times x raised to the power of negative 1 over 2 negative 1, which is negative 1 over 2 times x raised to the power of negative 1 over 2 negative 1 would give you negative 3 over 2. Of course, you can push it to the denominator. That's going to be 1 over 2 x raised to the power of positive 3 over 2. So this would be the outcome. If you want, you can always write x raised to the power of 3 over 2 as x raised to the power of 3, the whole raised to the power of 1 over 2, and then rewrite this as root of x cubed. You can do this, or if you're not happy with this, you can also do the other way. What is the other way? Instead of writing it like this, you can also write this x raised to the power of 3 over 2 as x raised to the power of 1 over 2 raised to the power of 3, which is nothing but root of x raised to the power of 3. Most of the times this would be the way in which you will be representing. So in fact, I can rewrite this as 1 over 2 with a negative sign and square root of x raised to the power of 3. Right? So this seems to be an ideal way. Of course, by the law of indices, you can interchange the exponents. That is always possible. Okay, students, we move on to the next question. So we expected to differentiate one positive cot x raised to the power of 4. The outcome is going to be 4 times, bring this down, of 1 positive cot x raised to the power of 4 negative 1 times, you will have to differentiate 1 positive cot x. Now this can be rewritten as 4 times of 1 positive cot x. 4 negative 1 will give you 3. Differentiation of 1 is going to be 0. Positive differentiation of cot x, I have already shown you, is going to be negative cosecant squared x. So if we were to rewrite this, this is going to be 4 times of 1 positive cot x raised to the power of 3 times negative cosecant squared x. I can further rewrite this as negative 4 times. I can place cosecant squared x outside multiplied with 1 positive cot x raised to the power of 3. So this is going to be the outcome. So question number 23, imagine if we are given something like this. Say d over dx of say x positive tan x raised to the power of some 2. This is what we have been given. So how are we going to do this? This is nothing but 2 times of x positive tan x raised to the power of 2 negative 1 times differentiation of x positive tan x. Now this can be further rewritten as 2 times of x positive tan x. 2 negative 1 will give you 1. Differentiation of x is going to be 1. Differentiation of tan x is going to be secant squared x. So I can either stop here, or probably I can write this as 2 times of 1 positive secant squared x times of x positive tan x. So this is the solution for this differentiation. So we will move on to the next question. So we will move on to the next question. So imagine you're given this, say d over dx, and you're expected to find x raised to the power of 3 times of 3x to the power of some 4 positive 1 raised to the power of say some 15. So this is what you have given, and you're expected to differentiate this quantity. So what are you supposed to do? Foremost, what you have to do is you will have to recollect the product rule. What is the product rule? D of uv is equal to u times v dash positive v times u dash. This is the product rule you should recollect. Now after recollecting this, you should assume or assign u to be equal to x to the power of 3 and my v to be equal to 3x to the power of 4 positive 1 raised to the power of 15. This is what you should do. Now from here, u dash is going to be 3 times x to the power of 3 negative 1, which is going to be 3 times x raised to the power of 2. This is my u dash. Now with reference to my v dash, I need to obtain my v dash, right? So let me do that here. So v dash is equal to 15 times 3 times x to the power of 4 positive 1 raised to the power of 15 negative 1. That's fine. Times differential of 3 raised to the power of x power 4 positive 1. You should do that. So this can be rewritten as 15 times 3 times x raised to the power of 4 positive 1. 15 negative 1 will give you 14. Differentiation of 3 times x to the power of 4 will give you 12 times x to the power of 3. Differential of 1 is going to be 0. So this is what you are going to get. Probably you can rewrite this as 15 times 12. So maybe you will have to multiply 15 with 12 and then take that value and then substitute it here, and then you got a x raised to the power of 3 times x raised to the power of 4 positive 1 raised to the power of 14. So this is my v dash. Okay, so now what you need to do is you need to go over here, okay, go over here and then substitute our product rule. So this is going to be equal to u, my u is x to the power of 3, my v dash is 180 x to the power of 3 times x to the power of 4 positive 1 times that has to be raised to the power of 14. So this is my v dash positive, my v is going to be 3 times x to the power of 4 positive 1 raised to the power of 15, that's my v, times my u dash is going to be 3 times x squared. Now clearly we can take some things out. So I can take x squared out, I can take 3 times x to the power of 4 positive 1 raised to the power of 14 out. So if I were to do that, I would clearly get probably, in fact I can also take a 3 out, right? So if I were to take a 3 out, this is going to give me 60. So this is 6 actually, so this is going to be x to the power of 4, and already we have taken 3x to the power of 4 positive 1, so that remains as it is, times 3 times x to the power of 4 positive 1, right? This is what we have got. So if you were to sum this up, this is going to give me 3 times x squared times 3 times x to the power of 4 positive 1 raised to the power of 14 times, I can add these two things, this is going to give me 63 x raised to the power of 4 positive 1. So this is going to be my output. So we've got this question. We are expected to differentiate x squared divided by x squared positive 1 raised to the power of 3. So foremost what we will do is we will use this formula, d of u over v is equal to v times u dash minus u times v dash divided by v squared, where I'm going to take my u to be as x squared and my v to be as x squared positive 1 raised to the power of 3. So my u dash is going to be 2 times x and my v dash is going to be 3 times of x squared positive 1 raised to the power of 3 negative 1 times differentiation of x squared positive 1. So this is going to be 3 times of x squared positive 1 raised to the power of 2. Differentiation of x squared is going to be 2x, differentiation of 1 is going to be 0. So I can rewrite this as 2 times 3, 6x times x squared positive 1 raised to the power of 2. This is going to be my v dash. Okay, so I've got my v dash, I've got my u dash, and now we need to obtain the solution. So this is equal to, so my v is x squared positive 1 raised to the power of 3 times u dash is going to be 2x negative my u is going to be my x squared, my v dash is this, so we have to substitute that 6x times x squared positive 1 raised to the power of 2 divided by my v squared, that's going to be x squared positive 1 raised to the power of 3, this has to be raised to the power of 2. So if I were to do that, this is going to give me 2x times x squared positive 1 raised to the power of 3 negative 6 times x to the power of 3 times x squared positive 1 raised to the power of 2 divided by x squared positive 1. 3 times 2 will give me 6. I can actually take x squared positive 1 out. In fact, raised to the power of 2 can go out. I can take 2 out. In fact, I can also take one x out. If I do that, 2x is already out, so this is going to be x squared positive 1, because x squared positive 1 raised to the power of 2 times x squared positive 1 will give me this term along with the 2x, that's fair enough, followed by a negative sign. I've got a 2, I've got an x, so this is going to be a 3 and an x, because in fact squared, because 2x times 3x squared will give me 6x to the power of 3, right? So divided by, I got x squared positive 1 raised to the power of 6. And what I can do, I can just cancel this entire thing with this thing, with the denominator. So that would give me 2 times x of x squared added with 3x squared. That's going to be 1 followed by negative 2 times x squared divided by x squared positive 1. This is 6, this is 2. So that would mean I would have a 4 here, right? So probably what I can do, is there anything else I can simplify? I cannot do anything else. I will have to stop here. So this is my d over dx of x squared divided by x squared positive 1 raised to the power of 3. Now we are expected to obtain the differentiation of e raised to the power of x. Now remember, differentiation of e raised to the power of x is always e raised to the power of x. So this is a standard formula that you will always have to remember. Now having known this, imagine you are asked to obtain the differentiation of say e raised to the power of 3x. So what would you do? Now differential of e raised to the power of 3x is going to be e raised to the power of 3x, no doubt about it. But you will have to follow this up with the differentiation of 3x. So what is that? So that is going to give you, differential of 3x is going to give you 3. So this is what you will have to have as the final solution. Now let me go a step further. So you got d over dx of e raised to the power of say 21x. What would you do? Directly you differentiate and write it as e raised to the power of 21x. The coefficient of x is 21. So that is going to be the solution for this particular question. Now instead of like this, suppose they are giving you like this, say obtain the differentiation of e raised to the power of say some 3x positive some 21. What would you do? Simple, differentiate this, write it as e raised to the power of 3x positive 21, and then you will have to differentiate this quantity 3x positive 21. What is that going to be? That's going to be e raised to the power of 3x positive 21 times differential of 3x will give you 3, differential of 21 is going to be 0. So this is going to be 3 times e raised to the power of 3x positive 21. So this is going to be the solution. Now moving on, let me just have this question. 1 over e raised to the power of 5x. How would you differentiate this? Now this can be rewritten as d over dx of, move this e raised to the power of 5x to the numerator. So you get it like this. You just, differential of e raised to the power of negative 5x is going to be e raised to the power of negative 5x times, you have to differentiate this negative 5x. What would that be? That's nothing but differential of negative 5x is going to be negative 5, which you can rewrite it like this. Negative 5 times e raised to the power of negative 5x. So ultimately what are you doing? You are obtaining the differential of e raised to the power of negative 5x, then you are multiplying by the coefficient of x, which is negative 5. That is what is exactly happening. So always remember that whenever you are getting differentiation with involving e. Now let us move on one step further. Suppose they ask you this question. Obtain the differentiation of say 21 divided by 1 positive, say 15 times e raised to the power of some 2x. So what would you do? Now whenever you are given like this, you have two quantities. So the best way is, I know you might think it is a little bit longer, but it doesn't matter as long as you are able to produce the right answer. So I'm going to use the quotient rule. So always I'm going to take u to be as the numerator, followed by the v to be as 1 positive, 15 times e raised to the power of negative 2x. Now differential of 21 is giving me 0, and differential of v, this is going to be 0, but this is a constant, so I can take it out. I'm actually differentiating e raised to the power of negative 2x, which is actually e raised to the power of negative 2x, but the coefficient of x is negative 2. So this can be rewritten as negative 30 times e raised to the power of negative 2x. So that is for my v dash. So if I were to obtain the differential, it's u over v. So the formula is, let me write the formula, d of u over v is v times u dash minus u times v dash divided by v squared. So I'm going to apply this formula. From this formula, my v is 1 positive 15 times e raised to the power of negative 2x. My u dash is 0, followed by my u is 21, and my v dash is negative 30 times e raised to the power of negative 2x, divided by my v is 1 positive 15 e raised to the power of negative 2x. That has to be raised to the power of 2. Now clearly this vanishes, so negative negative will become positive. So I can write that as 3 ones are 3, 3 times 2 is 6 with a 0 there, and e raised to the power of negative 2x divided by 1 positive 15 times e raised to the power of negative 2x raised to the power of 2. This is my differentiation for this particular quantity. Now alternatively, we can differentiate this in this following fashion. So what I'm going to do, I'm going to rewrite this as d over dx of, I'm going to push this to the numerator. So this is going to be 21 times 1 positive 15 times e raised to the power of negative 2x. Now when the quantity goes to the numerator, the exponent is actually positive 1 in the denominator. That would actually become negative 1. So this is what we have got. Now we will have to differentiate this. So don't worry about the constant, just retain the constant as it is and bring this exponent down. So it's going to be negative 1 times 1 positive 15 times e raised to the power of negative 2x, negative 1, you got to add another negative 1 times differentiation of 1 positive 15 times e raised to the power of negative 2x. So this is going to be negative 21 times 1 positive 15 times e raised to the power of negative 2x. Negative 1 will give you negative 2. Differential of 1 is 0. Now differentiation of 15 times e raised to the power of negative 2x. I have already told you 15 is a constant. So differential of e raised to the power of negative 2x is going to give you e raised to the power of negative 2x, but the coefficient of x is a negative 2, so that you can place that. So this is what you get. So now you will have to multiply everything. Now negative sign is there, there's a negative, negative times negative will be positive, so you got a 21 there. All these things are product, and then you got a 15 there, and then you got a 2 there, and then I have to multiply 1 positive 15 times e raised to the power of negative 2x raised to the power of negative 2 times e raised to the power of negative 2x. Now 15 times 2 is 30, so I have to multiply that with 21. So I got this quantity 1 positive 15 times e raised to the power of negative 2x raised to the power of negative 2 times e raised to the power of negative 2x. Now what I wish to do is I will multiply this with this, so that would give me 3 ones are 3, 3 times 2 is 6, there's a 0 there. I am placing e raised to the power of negative 2x. This is a negative exponent, so push it down. So you get 1 positive 15 times e raised to the power of negative 2x, and that has to be raised to the power of 2. Now what is all this? This is nothing but differentiation of 21 over 1 positive 15 times e raised to the power of negative 2x. So that is the final solution. You can check the final solution with the one that we just obtained using the other method, and you will find that both the methods bear the same solution and the output. Okay students, we got an interesting question. We are expected to find the differentiation of root of e raised to the power of x, positive e raised to the power of root of x. Now let me just explain to you what exactly is this meaning of this root of e raised to the power of x. Now suppose you have root of x power 5. This is nothing but x raised to the power of 5 raised to the power of 1 over 2, which can be rewritten as x raised to the power of 5 over 2. Now root of e raised to the power of x is nothing but e raised to the power of x. The entire thing is raised to the power of 1 over 2, which can be rewritten as e raised to the power of x over 2. So this understanding is important in solving this particular question. So I'm going to rewrite this as d over dx of e raised to the power of x over 2 positive d over dx of e raised to the power of root of x. Now this is similar to e raised to the power of x. The only thing is that we have to differentiate root of x separately. So now differential of this is going to give me e raised to the power of x over 2 times differentiation of x over 2 followed by this is going to be e raised to the power of root of x times differentiation of root of x. So this can be rewritten as e raised to the power of x over 2. Differential of x over 2 will give me 1 over 2. I can write that positive e raised to the power of root of x times, this is actually, we have already studied this, differential of root of x can be written as differentiation of x raised to the power of 1 over 2 which is nothing but 1 over 2 x raised to the power of 1 over 2 negative 1, which is nothing but 1 over 2 times x raised to the power of negative 1 over 2, which I can rewrite it as 1 over 2 times root of x. This is the standard differentiation, but I just want to make sure that you understood this, so I've given you the steps here. So this is going to be 1 over 2 times root of x. If I were to club everything, I get 1 over 2 times e raised to the power of x over 2, positive 1 over 2 times root of x e raised to the power of root of x. I can rewrite this by taking 1 over 2 out. If I do that, I get e raised to the power of x over 2, positive e raised to the power of root of x divided by root of x. So this is what my final solution is. Now if you want, you can make it still further better. You can rewrite this as e raised to the power of x. This is raised to the power of 1 over 2 as we have obtained. So this is going to be e raised to the power of root of x divided by root of x. So this is equal to 1 over 2 times. This is going to be root of e raised to the power of x positive e raised to the power of root of x divided by root of x. What is this? This is nothing but differentiation d over dx of root of e raised to the power of x positive e raised to the power of root of x. So this is our final solution. Students, we expected to differentiate secant raised to the power of 4 of 3x. Okay, so this is actually the angle. So how are we going to differentiate? This is nothing but 4 times secant raised to the power of 4 negative 1 of 3x times differentiation d over dx of secant 3x times d over dx of 3x. So this is what we have to do actually. Now this is going to be rewritten as 4 times secant 4 negative 1 will give you 3 of secant 3x times differential of secant x. It's actually secant 3x. So that's going to be secant 3x times tan 3x. We have already seen the differentiation of secant x. Times differential of 3x, that's going to be 3. So 3 times 4 will give me 12 times secant to the power of 3 of 3x. In fact, there is another secant 3x. I could have multiplied it, but anyway, I will do it in the subsequent step. So this is going to be 12 times secant to the power of 4 of 3x times tan of 3x. So what is this? This is nothing but d over dx of secant to the power of 4 of 3x. So this is the solution to the question. Students, we expected to differentiate d over dx of 1 over 2 secant x tan x plus 1 over 2 times ln of secant x plus tan x. Now I am trying to finish this question in the space provided here. So let me see how best I can do that. Now I'm going to rewrite this. It's constant. 1 over 2 is a constant. So I'm going to take 1 over 2 out, and then I'm going to rewrite this as d over dx of secant x tan x, right? 1 over 2 is a constant, it's already taken out. So plus d over dx of ln of secant x plus tan x. So this is what we have got. Now this is equal to 1 over 2 times differential of secant x tan x. Now we have to apply UV method. Okay, without that it's not possible. It's better that we apply UV method. So I'm taking u is equal to secant x, and then my v is equal to tan x. So differential of secant x will give me secant x tan x, and differential of tan x is going to give me secant squared x. So if I were to apply UV method, u times v dash positive v times u dash, my u is secant x, my v dash, this is v dash, is secant squared x, plus my v is tan x, and my u dash is secant x tan x. So I can rewrite this as secant cubed x positive secant x times tan squared x. What is this? This is what we get when we differentiate secant x tan x. So let me write that down. So what is that? I get a secant cubed x. Of course I would have taken secant x out, but it doesn't matter. So it's going to be secant x times tan squared x positive. Now log x differentiation. Now that is a very important concept that you will have to know. Now I get y is equal to ln x, right? Now if someone were to ask you what is dy over dx, that's nothing but 1 over x. This is natural logarithm, but the same thing will happen for y is equal to log x. So dy over dx is going to be 1 over x. Now if you get y is equal to ln x squared and they are asking you to find dy over dx, then it's going to be 1 over x squared times differentiation of x squared. You need to do that. So that would give me differentiation of x squared is going to be 2x divided by x squared. Of course I can rewrite this as 2 over x. But the most important point you will have to do here is, once you bring the quantity that is attached with logarithm down, instantaneously you have to differentiate that quantity. That is the most important aspect you will have to know here. So I'm differentiating this quantity. So it's going to be 1 over, clearly, secant x plus tan x times, I need to differentiate the quantity secant x plus tan x. That is critical. Okay. So when I do that, what do I get? I get 1 over 2. This is going to be secant cubed x plus secant x times tan squared x positive 1 over secant x positive tan x times differential of secant x is going to give me secant x tan x positive differential of tan x is going to give me secant squared x. So this is what I've got. So now the question comes is, I have to probably, I can either stop here or probably attack or attach some level of simplification. The only simplification I can think of is, if I were to take secant x out, I will get tan x plus secant x here. So we can do that simplification. So let me just show you that. So this is equal to 1 over 2 times, I'm taking secant x out. That is going to give me secant squared x plus tan squared x. That's fine. Now positive, I can take secant x out. If I take secant x out, I would get tan x plus secant x divided by secant x plus tan x, right? Now clearly secant x plus tan x goes away. Now I have a secant squared x plus tan squared x. Does it ring any bells to you? So let me show you this over here. Secant squared x plus tan squared x. I can always write, I'm showing you here, secant squared x plus tan squared x as 1 over cos squared x plus sin squared x divided by cos squared x. So 1 positive sin squared x divided by cos squared x. So I will have to settle. I cannot perform any simplification. I will have to just settle with this. So if I were to rewrite this, okay, I can rewrite this as, I got a secant x, I got a secant x. Probably I'll take 1 over 2 out. It's actually out. So if I were to take secant x out, then this entire thing is going to be 1 positive secant squared x plus tan squared x. In fact, probably this parenthesis should have been an ideal one. However, just in case if you want to further simplify this, let me just show that to you over here in this space. So this is, there is a formula which states that secant squared x negative tan squared x is equal to 1, and from here I can rewrite secant squared x as 1 positive tan squared x. So if I were to use 1 positive tan squared x is equal to secant squared x, then I've got secant squared x positive secant squared x. So that would mean I can rewrite this entire thing as 1 over 2 times secant squared x, positive secant squared x, that's going to be 2 secant squared x, and a 2 over here and a 2 can be cancelled. Secant x times secant squared x is going to give me secant cubed x. So this would be the solution if you are expected to simplify this result further. So we'll move on to the next question. Students, we got question number 35, which is differentiation of x times e raised to the power of 2x divided by 1 positive e raised to the power of 2x. Now I'm going to take this as u. U is x times e raised to the power of 2x, and my v is 1 positive e raised to the power of 2x. Now differentiation of u, this has got two terms, so it's going to be uv differentiation, which is nothing but u times v dash, positive v times u dash. So if I were to take that, it's going to be x times differentiation of e power 2x is going to be e power 2x. The coefficient of x is 2, so place that. Positive e raised to the power of 2x times differentiation of x is going to be 1. So if I rewrite this, it's going to be 2 times x times e raised to the power of 2x, positive e raised to the power of 2x, which can be rewritten as e raised to the power of 2x of 2x positive 1, which is my u dash. So you can box this in one particular spot. Now going on to my v dash, differentiation of 1 is 0, differentiation of e power 2x is e power 2x, the coefficient of x is 2, so this is going to give me 2 times c raised to the power of 2x, this is v dash. So therefore this quantity is going to be, I'm going to be using this formula, d of u over v is v times u dash minus u times v dash divided by v squared. So my v is 1 positive e raised to the power of 2x, my u dash is going to be e raised to the power of 2x times 2x positive 1, negative my u is x times e raised to the power of 2x, my v dash is 2 times e raised to the power of 2x divided by my v is 1 positive e raised to the power of 2x raised to the power of 2. Now I can simplify this. Probably I can maybe reduce this in this following fashion. So let's see how we can do that. So I can multiply is okay. The only thing I can do is I can take e power 2x out. So if I were to take e power 2x out, this would give me 2x positive 1 times 1 positive e raised to the power of 2x, and then I've taken e raised to the power of 2x out, so this is going to be minus 2 times x e raised to the power of 2x divided by 1 positive e raised to the power of 2x raised to the power of 2. Now this is e raised to the power of 2x. Probably I can simplify this, 2x times e raised to the power of 2x, and then 2x times 1, and then 1 times 1 positive e raised to the power of 2x, negative 2x times e raised to the power of 2x divided by 1 positive e raised to the power of 2x raised to the power of 2. Now clearly 2x times e raised to the power of 2x, negative 2x times e raised to the power of 2x can be cancelled, giving me 1 positive 2x positive e raised to the power of 2x times e raised to the power of 2x divided by 1 positive e raised to the power of 2x raised to the power of 2. This is my d over dx of x times e raised to the power of 2x divided by 1 positive e raised to the power of 2x. So this is the answer to the differentiation. So we got this question. We expected to differentiate e raised to the power of 3x times cos of x squared divided by 2. I'm going to take my u to be as e raised to the power of 3x
and v to be as cos of x squared over 2. Differentiation of this is going to be e raised to the power of 3x. Quotient of x is 3, and differentiation of this is going to be negative sine of x squared over 2 times differentiation of x squared over 2, which is equal to negative differentiation of this is going to be 2x over 2 times sine of x squared over 2. The 2 and the 2 can be cancelled, giving me negative x times sine of x squared over 2, which is my v dash. So if I were to apply this u over v, u times v formula, which is nothing but u times v dash, positive v times u dash, which is e raised to the power of 3x, my v dash is negative x times sine of x squared over 2, positive my v is cos of x squared over 2, times my u dash is 3 times e raised to the power of 3x, which I can rewrite as negative x times e raised to the power of 3x sine of x squared over 2, positive 3 times e raised to the power of 3x cos of x squared over 2. I can take e raised to the power of 3x out and then write 3 times cos of x squared over 2 negative x times sine of x squared over 2. Right? So this is going to be my differentiation of d over dx of e raised to the power of 3x times cos of x squared over 2. So that is the solution. So we expected to differentiate 1 over 5th root of x raised to the power of 4 negative 2. I'm going to rewrite this as d over dx of 1 over x raised to the power of 4 negative 2. This is raised to the power of 1 over 5. Now I can take it to the numerator, so that's going to be d over dx of x to the power of 4 negative 2 raised to the power of negative 1 over 5. Now I'm going to differentiate this. This was going to give me 1 over 5 times x to the power of 4 negative 2 raised to the power of 1 over 5 negative 1 times differentiation of x power 4 negative 2. This is going to be negative 1 over 5 times x to the power of 4 negative 2. This is going to be 1 over 5 negative 1, which is negative 1, followed by negative 5 over 5, which is negative 6 over 5. I'm just taking the LCM. So that's going to be negative 6 over 5. Differentiation of x power 4 is 4 times x power 3. Differentiation of 2 is going to give me 0. I can rewrite this as 4 times x to the power of 3. I can push this down. So this is x power 4 negative 2 raised to the power of 6 over 5. I get a negative 1 over 5. So I can literally write it like this, or probably I can write it like this: negative 4 times x to the power of 3 divided by 5 times. Now this is going to be x to the power of 4 negative 2 raised to the power of 6 raised to the power of 1 over 5, right? So subsequently we can rewrite this as negative 4 times x to the power of 3 divided by 5 times 5th root of x to the power of 4 negative 2 raised to the power of 6, which is my differentiation of 1 over 5th root of x to the power of 4 negative 2. So that is the solution that we have got for this question. Students are expected to differentiate tan inverse of square root of x squared positive 3. Now foremost, it is imperative that we know what is differentiation of tan inverse of x, which is nothing but 1 over 1 positive x squared. This is a standard formula which you have to know. Over here we have been given tan inverse of square root of x squared positive 3. So this is going to be 1 positive. In place of x we have to have root of 3 positive x squared. This is raised to the power of 2, right? That's fair enough, times derivative, differentiation of square root of x squared positive 3. So that's what we have to do. Now let me just show you this differentiation. I have to differentiate root of x squared positive 3. I can rewrite this as d of x squared positive 3 raised to the power of 1 over 2. Right, so this differentiation is going to be 1 over 2 times x squared positive 3 raised to the power of 1 over 2 minus 1 times differentiation of x squared positive 3. This is going to be x squared positive 3 raised to the power of negative half. Differentiation of x squared is 2x, differentiation of 3 is 0. I already have a 1 over 2 here. So this can be rewritten as 2x. Okay, anyway, this 2 and this 2 can be cancelled. So this is going to be x. I can push this down. So this is going to be root of x squared positive 3. This is for differentiation of root of x squared positive 3. So if I were to rewrite this, this is going to be x over 1 positive. Now root of 3 positive x squared, that's raised to the power of 2. So the 2 and the radical sign gets cancelled, giving me x squared positive 3 times, I already have, I placed the x here, then this has to be multiplied by root of x squared positive 3. So what is this? This is nothing but d over dx of tan inverse of root of x squared positive 3. However, you can simplify this. You can add 3 with 1 and that would give you 4. So you can rewrite this as x over x squared positive 4 times square root of x squared positive 3. So this is the good place to stop for the solution. So students, we expect to differentiate ln of x squared divided by x to the power of 4. Now I would be taking u to be as ln of x squared and my v to be as x to the power of 4. My u dash is differentiation of ln of x squared, which is 1 over x squared times differentiation of x squared. This is going to give me 2 times x divided by x squared, which is nothing but x and x get be cancelled, giving me 2 over x. So this is my u dash. Now coming to my v, differentiation of v is going to give me 4 times x to the power of 3. So if I were to use this formula, d of u over v, this is going to be v times u dash minus u times v dash divided by v squared. My v is x to the power of 4. My u dash is 2 over x negative. My u is ln of x squared. My v dash is 4 times x to the power of 3 divided by my v is x to the power of 4, that has to be raised to the power of 2. Now clearly x and x can be cancelled, giving me 2 times x to the power of 3. I can rewrite this as 4 times x to the power of 3 ln of x squared divided by x to the power of 8. If I were to take x to the power of 3 out and 2 out, I would get 1 negative 2 times ln of x to the power of 2 divided by x to the power of 8, which is nothing but 2 times of 1 negative 2 times of ln x squared divided by x to the power of 5, which is my d over dx of ln of x squared divided by x to the power of 4. Now we got this question, we expected to differentiate x to the power of x. So to differentiate this, we have to adopt a different strategy. Now it is imperative to understand that if I've got something like this, e raised to the power of ln x, this is nothing but x. Now just going a little bit further, if I were to have say e raised to the power of ln x raised to the power of x, this is nothing but x power x. So this is exactly what I'm going to do. So wherever I see x power x, I'm going to substitute it as e raised to the power of ln of x raised to the power of x. So this is rewritten as d over dx of e raised to the power of ln of x raised to the power of x. Fair enough. Now there is a property, ln of a raised to the power of b can be rewritten as b times ln a. So by this I can rewrite this as d over dx of e raised to the power of x times ln x. Now this is actually e raised to the power of x. So when you differentiate, you're going to get e raised to the power of this quantity, x times ln x, times you have to differentiate x times ln x. So this is going to be UV form. So just to have a recap, if you got u times v, it's going to be u times v dash positive v times u dash. So this is the formula we will be applying over here. So this is going to be e raised to the power of x times ln x times u times differential of ln x, which is 1 over x, positive v, which is ln x times differentiation of x, which is 1. So this can be further rewritten by cancelling the x terms. So I got e raised to the power of x times ln x of 1 positive ln x times 1. In fact, it's actually 1 time ln x, so we would just simply get ln x. Of course, if you want to further simplify this, you can move this x over here. So this can be rewritten as e raised to the power of ln of x raised to the power of x of 1 positive ln x. Of course, e and ln, they can be neutralized, giving us x raised to the power of x times 1 positive ln x. So this is a good place to stop, and we move on to the next question. Students, we are given a question: find dy over dx if x raised to the power of 5 positive y raised to the power of 5 is equal to 5 times xy. Now x is an independent variable, y is a dependent variable. So we would start off by this statement: differentiating with respect to x, we get. So differentiation of x to the power of 5 would give us 5 times x to the power of 4, positive differentiation of y power 5 would give us 5 times y raised to the power of 4 times differential of y, which is dy over dx, is equal to 5 times. Now we have to apply UV technique here. So x times differentiation of y, which is dy over dx, positive y times differentiation of x, this is what we get. So I can rewrite this as 5x times dy over dx positive 5 times y. This is going to be 5 times x to the power of 4 positive 5 times y power 4 times dy over dx. I can move this dy over dx this side, so this can be rewritten as dy over dx of 5 times y raised to the power of 4 negative 5 times x is equal to, I can move this to the other side, so it's going to be 5y negative 5 times x to the power of 4. Taking 5 out, this is going to be y negative x to the power of 4. On the left side, I can take 5 out, so it's going to be 5 times dy over dx of y raised to the power of 4 negative x. My 5 and 5 can be cancelled. I need only dy over dx, so I can rewrite, therefore dy over dx is equal to y negative x to the power of 4 divided by y raised to the power of 4 negative x. So this is a good place to stop, and we have achieved our objective. Our objective is to find dy over dx, and we have just exactly done that. So students, we are expected to differentiate and find dy over dx. In this case, we are given y times cos y is equal to x times cos x. So foremost, we will apply UV technique. So let me write the formula. D of u times v is u times v dash positive v times u dash. So by this formula is going to be y times differential of cos y, that's going to be negative sine y, times differentiation of y, which is dy over dx, positive cos y times differential of y, which is dy over dx. So this is equal to u into v. So x times differential of cos x is going to be negative sine x, positive cos x times differential of x is going to give me 1. So if I were to take dy over dx out, this is going to give me negative y times sine y, positive cos y is equal to x times sine x, positive cos x. So I want dy over dx, so I can push this. So therefore dy over dx is equal to, I'm going to write this as cos x negative x times sine x divided by cos y negative y times sine y. This is my final solution. Students, we are given this question. We are expected to find dy over dx, and we have got ln of x squared over y is equal to e raised to the power of x times y raised to the power of 5. So I would be differentiating with respect to x both sides. So when I do that, differentiation of ln is going to be 1 over x squared over y times differentiation of x squared over y, which is equal to, on the right hand side I have to differentiate this, so this is going to be e raised to the power of x times y raised to the power of 5 times differentiation of x times y raised to the power of 5. So I'm going to use the space over here. So 1 over x squared over y, you can flip it and write it as y over x squared times, this is u over v. So let me write down the formula for u over v. So d differentiation of u over v is going to be v times u dash minus u times v dash divided by v squared. So I will be using this formula for this. So that's going to be y times differentiation of x squared is going to be 2x, negative x squared times differentiation of y is going to give me dy over dx divided by my y is v, so it's going to be y squared, right? So on the right hand side it's going to be e raised to the power of x times y raised to the power of 5, differentiation of this is going to be u times v, which is nothing but u times v dash positive v times u dash. So I'm going to use this formula. So differentiation of x times y raised to the power of 5 is nothing but u times v dash. So it's going to be x times 5 times y raised to the power of 5 minus 1 is equal to 4. Differentiation of y, which is dy over dx, positive y raised to the power of 5 into differentiation of x, which is equal to 1. So I can rewrite this as e raised to the power of x times y raised to the power of 5 of 5 times x y raised to the power of 4 times dy over dx positive y raised to the power of 5. So I can take a y raised to the power of 4 out. So this is going to be y raised to the power of 4. Of course I got a e x raised to the power of 5 of 5 times x dy over dx positive y raised to the power of 4 is already gone, so this is going to give me y. So this is for the right hand side. So on the left hand side we will have to simplify this. So let me use the space here. So this is going to be, by the way, all of these things are the formulae which we have used. So let me just place this in red so that there exists an element of clarity. So coming to the left hand side, this is going to be y over x raised to the power of 2. Now I can rewrite this as 2 times xy negative x squared times dy over dx divided by y raised to the power of 2 is equal to, however I got this quantity, right? So let me write this quantity, y raised to the power of 4 e raised to the power of x times y raised to the power of 5 times 5 times x times dy over dx positive y. Now I need to extract dy over dx, right? So for that let me just multiply the things up, remove the parenthesis. So this is going to be, I need to remove the parenthesis. So 5 times x times, of course I get y raised to the power of 4 times dy over dx. Of course I need to place that e raised to the power of x times y raised to the power of 5. So that is fine. Positive, this is y raised to the power of 5 e raised to the power of x times y raised to the power of 5. In fact, we could have got the step a little bit earlier instead of taking y raised to the power of 4 out, but it's okay, we have done it. Now the point is I need to get rid of this y squared, so I cross multiply. Now if I cross multiply, this is going to be y raised to the power of 2 here, and on the left hand side I get a y over x squared times 2 times xy negative x squared times dy over dx. So this is what I've got. Of course I need to remove the parenthesis. If I remove the parenthesis, I am multiplying by y over x squared throughout. So this is going to give me 2 times x and x can be cancelled, so that's going to be 2 times y squared divided by x negative x squared gets cancelled, giving me y
times dy over dx is equal to e raised to the power of x times y raised to the power of 5 times 5 times x times y raised to the power of 4 times dy over dx positive. In fact, I could have multiplied this inside. So if I multiply this inside, this will become y raised to the power of 6, right? Positive y raised to the power of 7 e raised to the power of x times y raised to the power of 5. So this is what I've got. Now what I wish to do is I wish to move this to the right hand side. So this is going to be 5 times e raised to the power of x y raised to the power of 5 times x times y raised to the power of 6 times dy over dx positive y times dy over dx. I'm moving this to this side. So this is going to be 2 times y squared over x negative y raised to the power of 7 times e raised to the power of x times y raised to the power of 5. Now I can take dy over dx out. That is because this is the requirement. So this is going to be 5 times x times y raised to the power of 6 times e raised to the power of x times y raised to the power of 5 positive y. And on the left I get 2 times y squared over x negative y raised to the power of y raised to the power of 7 of e raised to the power of x raised to the power of x times y raised to the power of 5. So I need to push this down. So if I push this down, I can state therefore dy over dx is equal to 2 times y squared over x negative y raised to the power of 7 e raised to the power of x times y raised to the power of 5, right, divided by 5 times x y raised to the power of 6 e raised to the power of x y raised to the power of 5 positive y. Now I can take y squared out. So I take y squared out. If I take y squared out, this is going to give me 2 over x negative y raised to the power of 5 e raised to the power of x y raised to the power of 5. That's fine, divided by, if I were to take, this is y power 6, right? So I can take y out. So if I take y out, this is going to give me 5x y raised to the power of 5 e raised to the power of x times y raised to the power of 5 positive 1. Probably I can just cancel y, and that's going to be giving me y of, if you want to take the LCM, you can just take the LCM, or else you can just leave it as it is. So I'm just going to leave it as it is. 2 over x negative y raised to the power of 5 e raised to the power of x times y raised to the power of 5. This is one quantity, divided by 5 times x y raised to the power of 5 e raised to the power of x y raised to the power of 5 positive 1, which is nothing but my dy over dx. So this is the solution for the question. Students, we are expected to find dy over dx, and the question is x is equal to secant of y squared. So what I wish to do is I would be differentiating with respect to x both sides. Now when you do the differentiation of x is going to give you 1. Now you got to know the differentiation of secant x will give you secant x tan x. Have that in mind. So this is a very important formula. We have already seen this and we will be using this. So differentiation of secant of y squared will give me secant of y squared times tan of y squared into differentiation of y squared. So this can be rewritten as secant of y squared into tan of y squared. Differentiation of y squared is going to be 2 times y into differential of y, which is dy over dx. So I'm going to rewrite this as 2 times y secant of y squared times tan of y squared into dy over dx. On the left side I've got 1. So I need to go obtain dy over dx. So bring everything to the left. So therefore I'm going to rewrite this as dy over dx is equal to 1 over 2 times y secant of y squared times tan of y squared, right?
Now what I wish to do is, I know that secant x is equal to 1 over cos x, and tan x is sin x over cos x. So I would like to use that formula. So it's going to be 1 over 2i, 1 over cos of y squared times sine of y squared divided by cos of y squared. So if you flip this, you will get cos of y squared times, in fact you got one more, you got another cos of y squared. Cos of y squared divided by 2 times y and the sine of y squared. So this can be rewritten as cos squared of y squared divided by sine of y squared. Now if you want, in fact it's up to you. If you want, you can write it like this. Of course there is a 2y there. If you want, you can stop here, or what you can do is you can club these two together, cos and sine. So that would mean you will have cot of y squared times cos of y squared divided by 2 times y. On the left hand side you got dy over dx. So this is the solution. Of course the right place to stop. You can, if you want, you can adopt different techniques of manipulation to get at the solution you want. I would like to show you another variation for the same question. So what I would like to do is, you will have to use this formula. Differentiation of secant inverse of x is equal to 1 over x times the root of x squared negative 1. So this is the formula we will be using. Now how we will be using the formula, what I will do is I will take this as 1 and then I will rewrite 1 as, I'm moving the secant to the other side. So this is going to be secant inverse of x is equal to y squared. Okay, so now we can differentiate with respect to x both sides. So when you do that, this is nothing but differentiation of secant inverse of x. This is differentiation of y squared. Differentiation of secant inverse of x is nothing but 1 over x times root of x squared negative 1. Differentiation of y squared is going to be 2 times y dy over dx, but we need only dy over dx. So therefore dy over dx is equal to, I'm going to bring this 2y down. So if I were to do that, I would get 1 over 2 times y times x times root of x squared negative 1. So this is my dy over dx. Of course, you might be wondering, how is it that we are having cot of y squared over here and cos of y squared over here? That might be your concern. Now I'm going to annihilate that concern. Now if I were to take this secant of y is equal to x over 1, therefore by Pythagoras, if you were to draw the Pythagoras, and this angle is y and this region is x and this region is 1, now clearly this is going to be root of x squared negative 1. Right, now I'm taking here as y. Now the reason I'm taking here as y is because secant y is equal to x. That is the reason. Now you are free to choose the angle. Now with this in perspective, we can clearly see that cot, what is cot? If I were to take cot y is nothing but 1 over tan y. Now what is tan? Tan is nothing but opposite side by adjacent, right? So this is nothing but 1 over opposite side by adjacent. So it's going to be root of x squared negative 1 divided by 1, which is nothing but my cot y. So my cot y is nothing but 1 over root of x squared negative 1. So have that in one corner of your mind. Now the next comes is cos. Now what is cos? So if I were to take cos y, so cos y is nothing but adjacent side by hypotenuse. So it's going to be 1 over x. This is my cos. Okay, now I have a cos, I have my cot. So what I need to do, I need to substitute. So what is this? depending on the angle is y squared, it doesn't matter. Okay, the angle is y squared, right? So it's a cot of y squared. So cot of y squared, instead of y we are going to have y squared. So the formula that we will have to place here for cot of y squared is going to be 1 over root of x squared negative 1. So this is my cot times my cos. My cos I've already told you 1 over x, so that's going to be 1 over x. But already there is a 2y there, so we can just place that 2y there. So you can compare this. So what is this? This is 2xy times root of x squared negative 1. So root of x squared negative 1. So both of these are one and the same. So in this case, what I did, I just used this all important formula. The differentiation of secant inverse of x is 1 over x times root of x squared negative 1. So two different ways I have shown you how to solve this question. So we move on to the next one, students. Students, we are given this question, x negative y raised to the power of 3 is equal to cos x positive cos y. We are expected to find dy over dx. So foremost, what I'm going to do is I'm going to be differentiating with respect to x both sides. So when I do that, this is going to give me 3 times of x negative y raised to the power of 2 times differentiation of x negative y. This is equal to differential of cos x will give me negative sin x. Differentiation of cos y will give me negative sin y times dy over dx. Differential of y is going to be dy over dx. So on this side I'm going to have 3 times of x negative y raised to the power of 2. Differentiation of x is going to be 1. Differentiation of y is going to give me dy over dx, which is equal to negative times sin x negative sin y times dy over dx. Now I can remove the parenthesis, so it's going to be 3 times of x negative y raised to the power of 2 negative 3 times of x negative y raised to the power of 2 times dy over dx is equal to negative sin x negative sin y times dy over dx. Now negative sin y dy over dx, you can bring this to this side, so it's going to be sin y times dy over dx negative 3 times of x negative y raised to the power of 2 dy over dx. Okay, so all I'm doing is I'm just connecting this with this, right? So on the right hand side it's negative sin x. I want to bring this term to the other side, so it's going to be negative of 3 times x negative y raised to the power of 2. So if I were to take the negative sign out, this is going to give me sin x positive 3 times x negative y raised to the power of 2. On the left hand side I got dy over dx, and then I can take sin y negative of 3 times of x negative y raised to the power of 2. Now I need dy over dx, so therefore my dy over dx is equal to negative of sin x positive 3 times of x negative y raised to the power of 2 divided by sin y negative of 3 times of x negative y raised to the power of 2. This is what I have got. If you want to get rid of the negative sign, probably you can take a negative sign out. So this will be negative, this will be positive. So these two negatives will be cancelled out. So thereby you can rewrite this as sin x positive 3 times x negative y raised to the power of 2 divided by 3 times of x negative y raised to the power of 2 negative sin y. So this is my dy over dx, and this is the solution for this question. Students, we have got this question, x raised to the power of y is equal to y raised to the power of x. This is a very important question. It occurs in a lot of entrance examinations as well as in the university level exams also. Now to handle this, what we are going to do is we are going to be taking ln both sides. So when we do that, this is going to give me ln x to the power of x is equal to ln y raised to the power of x. Now I know the formula that ln a raised to the power of b is equal to b times ln a. So by this formula, this is going to be rewritten as x times ln of x is equal to, in fact, this is y, right? So this is going to be y times, let me rewrite it again, y times ln x is equal to x times ln y. Now what I wish to do is I would be differentiating both sides with respect to x. So u into v formula. So the formula is d of u times v, which is u times v dash positive v times u dash. So this is a formula which we would be using. So this is going to be y times differential of ln x is 1 over x positive ln x, differential of y is dy over dx is equal to x times differential of ln y is 1 over y times dy over dx positive ln y times differential of x. We can rewrite this as x over y times dy over dx positive ln y. On the left hand side it is going to be dy over dx times ln x positive y over x. I need dy over dx, so what I would do is I will bring this to the left hand side. So this is going to be dy over dx of ln x negative x over y is equal to ln y. I'm going to push this to the other side, so it's going to be minus y over x. Now I can rewrite this as x times ln y negative y divided by x. This is one term. If I were to bring this down, this is going to be y times ln x negative x divided by y. So if I were to flip this, so let me just use the space here. So if I were to flip this, this is going to be x times ln y negative y divided by x times of y times ln x negative x. This is one term. So if I flip this, this will go to the numerator. So I can place this over here and write it like this. So this is my dy over dx. So if you want, you can write this a little bit more with clarity. So it's going to be y times x times ln y negative y divided by x times y times ln x negative x. So this is a good place to stop for my dy over dx. Students, we are expected to find dy over dx for this question. We've got tan inverse of x cubed y is equal to x squared positive y raised to the power of 5. Now we know that tan inverse of x is equal to 1 over 1 positive x squared. If you were to differentiate this using this formula, first what we'll have to do is differentiating with respect to x both sides. We get, so this is 1 over 1 positive x cubed y raised to the power of 2 times differentiation of x to the power of 3 times y is equal to, on the right hand side, differential of x squared is 2x, differential of y power 5 is 5 times y raised to the power of 4 times dy over dx. I can rewrite this again by differentiating x to the power of 3 times y. Now in this case I'm going to use u over v formula, I mean u times v formula, which is u times v dash positive v times u dash. So this is going to be x to the power of 3 times dy over dx positive y times differential of x power 3 is 3 times x squared divided by 1 positive. I can rewrite this as x power 6 and y squared, right? So on the right hand side I get 2 times x positive 5 times y raised to the power of 4 times dy over dx. Now we will have to get dy over dx, so I will cross multiply. So if I cross multiply, this is going to be 2 times x of 1 positive x power 6 y raised to the power of 2 positive 5 y raised to the power of 4 times 1 positive x power 6 y squared times dy over dx on the right hand side. On the left hand side I get x to the power of 3 dy over dx positive 3 times x squared y. This is what I've got. Now what I can do is I can push this to this side, I can move this to the other side. So this is going to be 3 times x squared y negative 2 times x of 1 positive x power 6 y squared. This is one term. As I mentioned to you, I will be retaining this on the right side, y power 5 times y power 4 times 1 positive x to the power of 6 y squared times dy over dx, and then I'm moving this, so this is going to be negative x to the power of 3 dy over dx. So if I were to take dy over dx out, this would give me 5 times y raised to the power of 4 times 1 positive x raised to the power of 6 y raised to the power of 2 for the first quantity, followed by x to the power of 3 for the second quantity. Of course the left hand side remains, I'm not doing anything, but I want dy over dx. So now we can conclude dy over dx is equal to, I need to push everything down. So the numerator is 3 times x squared y negative 2 times x of 1 positive x power 6 y raised to the power of 2. This is the numerator, divided by the denominator is y raised to the power of 4 times 1 positive x raised to the power of 6 y squared negative x raised to the power of 3. This is a good place to stop. If you have this question in objective, based on your requirement, you can simplify this and get the answer. So students, we have reached here, and we will move on to other challenging questions in differentiation. Students, we are given this question: x squared over x squared negative y squared is equal to 3 times y squared. We are expected to find dy over dx. So foremost, what we will have to do is we will have to cross multiply this and rewrite this as x squared is equal to 3 times y squared of x squared negative y squared. Now I'm just doing it like this, but you are free to use the quotient rule and still you will be able to obtain the result. So I'm going to distribute these things. So this is going to be 3 times y squared times x squared negative 3 times y raised to the power of 4. Now what I'm going to do is I'm going to be differentiating with respect to x both sides. So when I do that, I would get, when I differentiate x squared, I will get 2 times x. This is 3 is a constant, so I'm taking it out. So I will be applying u-v method. So differentiation of u times v is u times v dash positive v times u dash. So this is what we have got. So this would be y squared times differentiation of x squared, that's 2x, positive x squared times differentiation of y squared, which is 2 times y dy over dx, followed by negative 3 of differentiation of y to the power of 4 is 4 times y raised to the power of 3 times the differentiation of y, which is dy over dx. So we would rewrite this as 3 times 2 is 6x y squared positive 6x squared y times dy over dx, negative 3 times 4 is 12 y raised to the power of 3 times dy over dx. Now I would like to take dy over dx out, so that would mean I would now have 6 times x squared y negative 12 times y cubed. So on the left hand side we already differentiated x squared, so we have a 2x and a 2x, and what I would do is I would move this to the left side. So it's going to be 2x negative 6 times x y squared is equal to dy over dx of 6 times x squared y negative 12 times y cubed. Now we need dy over dx, so what I would do is I would try to bring this down. So therefore dy over dx is equal to 2 times x negative 6 times x y squared over 6 times x squared y negative 12 times y cubed. I can take a 2 out, x out, so that would give me 1 negative 3 times y squared divided by, I can take 6 out,
y out, so that is going to give me x squared followed by 2 times y squared, right? 6y x squared gives me 6x squared y, and 6y times 2 times y squared gives me 6 times 2, 12 y to the power of 3. So this is my dy over dx. Probably this is a good place to stop for this question, and we'll move on to the next one. Students, we are expected to find dy over dx for this particular question. We've got e raised to the power of x squared over y is equal to x squared positive y, and we need to get the dy over dx. So what I wish to do is differentiating with respect to x, we get, so we are differentiating with respect to x both sides, and that would mean differentiation of e raised to the power of x squared over y would give me e raised to the power of x squared over y times differentiation of x squared over y is equal to differentiating x squared positive y would give me 2 times x, positive differentiation of y is going to be dy over dx. I wish to use this side, so I will be continuing here. So this is e raised to the power of x squared y. Now this is quotient rule, so d of u over v is equal to v times u dash minus u times v dash over v squared. So in this case my u is x squared and my v is y, so u dash is 2x and my v dash is dy over dx. So using this formula, my v is y, so it's going to be y times with the differentiation of u dash, so differentiation of u dash would be 2x followed by negative u is x squared, and differentiation of v, my v is y, so it's going to be dy over dx. This is for the numerator, divided by the denominator is going to be y squared, so it's going to be y into differential of this quantity 2x followed by a negative sign and x squared times differentiation of this divided by y raised to the power of 2, which is equal to, on the right side I got 2x positive dy over dx. Now we need to simplify this. I can cross multiply and rewrite this as e raised to the power of x squared over y times 2 times xy negative x squared times dy over dx. Since I have cross multiplied with y squared, this is 2 times x y squared positive y squared times dy over dx. Now I need dy over dx, so what I'm going to do, I'm going to remove the parenthesis by distributive property, so that would give me 2 times xy e raised to the power of x squared y negative e raised to the power of x squared y times x squared times dy over dx is equal to 2 times x y squared positive y squared dy over dx. So now I need to obtain dy over dx. So what I wish to do is I wish to move this to the right side and bring this to the left side. So this is going to be 2 times xy e raised to the power of x squared over y negative 2 times x y squared. This is equal to, so we got y squared times dy over dx. I push this to the other side, so that would give me positive e raised to the power of x squared over y times x squared times dy over dx. So I'm moving over here. So the left side is 2xy e raised to the power of x squared over y negative 2 times x y squared is equal to, I'm taking dy over dx out, so that would give me y squared positive e raised to the power of x squared y times x squared. Since we need only dy over dx, so therefore dy over dx
is equal to 2 times x. In fact, I can take 2x and I can take a y out, right? So for this case, 2 is taken out, x is taken out, y is taken out. So I get e raised to the power of x squared over y. Since 2 is taken out, x is taken out, y alone remains. So we get a y there divided by, I need to push this guy down. So that is going to be y squared positive of e raised to the power of x squared y times x squared. So this is what we have got, and this is our solution. Students who are given this question, we are expected to find dy over dx. So the question is x cubed positive y cubed negative 2 raised to the power of 5 is equal to y squared. We are expected to get the differentials. So we will, as usual, start by writing the statement. Differentiating with respect to x both sides, we get. So differential of this entire quantity can be written as 5 times of x to the power of 3 positive y to the power of 3 negative 2 raised to the power of 5. You bring it down, you get 4, right? So times differentiation of this entire quantity. What is that? X to the power of 3 plus y to the power of 3 negative 2. This is equal to, differentiating the right side would give me 2 times y dy over dx. So this is what I've got. Now I can further simplify the left side, which is going to be 5 times of x to the power of 3 positive y to the power of 3 negative 2 raised to the power of 4 times differentiation of x cubed will give me 3 times x squared positive differentiation of y cubed will give me 3 times y squared times dy over dx. Of course, constant is going to be 0. This is equal to 2 times y dy over dx. The objective is to get dy over dx. So I take this entire thing and multiply and remove the parenthesis. So 5 times 3 is 15 of x squared of x to the power of 3 positive y raised to the power of 3 negative 2 raised to the power of 4. That's one quantity, followed by 15 times y squared of x to the power of 3 positive y raised to the power of 3 negative 2 raised to the power of 4 times dy over dx is equal to 2 times y dy over dx. Now my objective is to get dy over dx. So what I wish to do is I would like to move this quantity to the other side and then take dy over dx. So that's going to be dy over dx of 2 times y negative 15 times y squared of x to the power of 3 y to the power of 3 negative 2 raised to the power of 4. So this is for dy over dx. Now on the left side, so in this case I am writing as the right side. I hope you are able to follow what I am doing. So this is going to be remaining. So it's going to be 15 times x squared of x to the power of 3 positive y raised to the power of 3 negative 2 raised to the power of 4. So we need dy over dx, right? So therefore dy over dx is equal to, this is on the denominator, on the numerator. So 15 times x squared times x to the power of 3 positive y raised to the power of 3 negative 2 raised to the power of 4 divided by, I'm bringing everything down. So this is going to be 2 times y negative 15 times y squared of x to the power of 3 positive y raised to the power of 3 negative 2 raised to the power of 4. So this is going to be my outcome. Of course, we can, if you are required to simplify, we can simplify, but I think this is a good place to stop. Students who are given this question, x squared positive 19y squared is equal to 19. We are expected to find d squared y over dx squared. That means we are asked to differentiate the function twice.
Now d squared y over dx squared is nothing but d over dx of dy over dx. So what is the meaning of this? The meaning of this is, after you obtain dy over dx, you need to again differentiate it with reference to x. Simple as that. So we have been given x squared, this is given, right? We are given x squared positive 19 times y squared is equal to 19. So what I'm going to do, I'm going to be differentiating with respect to x both sides. So when I do that, differentiation with reference to x both sides, x squared is going to be 2x and 19 is a constant. Differentiation of y squared is going to be 2 times y times dy over dx is equal to differentiation of 19, that's going to be 0. Now I'm going to take 2x to the other side, so that would give me 19 times 2 times y times dy over dx is equal to negative 2x. I can cancel the 2's here, and then from here I would get dy over dx is equal to negative x over 19 times y. Now since we are asked to find d squared y over dx squared, I'm going to be differentiating this again. Differentiating again with respect to x, we get. So on the left hand side, this is actually d over dx of dy over dx. So this is the meaning of this, and we are differentiating this. So I'm writing it like d over dx of negative x over 19 times y. So this is nothing but my quotient rule. So what is that quotient rule? I'm going to write it down here. D of u over v is v times u dash minus u times v dash divided by v raised to the power of 2. So this is the formula I will be using. So it's going to be 19 times y times differentiation of negative x will give me negative 1 negative x times differentiation of 19y would give me 19 times dy over dx divided by 19 times y raised to the power of 2. Of course you can take the constant out and do the differentiation, but I've just retained the constant, it doesn't matter. So this is going to be negative 19y, negative positive 19 times x times dy over dx divided by 19 squared times y squared. Now you can use some algebraic property. So what is the algebraic property you can use? If you have got a positive b over c, you can rewrite it as a over c positive b over c. It doesn't matter, right? So I'm going to rewrite this as negative 19y divided by 19 squared times y squared followed by a positive sign 19 times x divided by 19 squared y squared times dy over dx. Now what I can do, I can cancel a 19, I can cancel a y, and this is going to be negative 1 over 19 times y. I can cancel a 19, so positive x times 19 times y squared times dy over dx. Okay, on the left hand side I've got d squared y over dx squared. Now there is a very important thing you will have to pay attention to. Now dy over dx can be replaced, which is negative x over 19y. So I'm going to substitute that. Now if I substitute that, I'm going to use this space here. I know the space is too small, but I'll try to squeeze it. So the outcome is going to be negative 1 over 19y positive dy over dx
is negative x over 19y. So x and x, so this is going to give me negative x and x squared, 19 and 19 squared, y and y squared gives me y to the power of 3. So if I were to rewrite this, this is going to give me negative 1 over 19y. I'm taking a y out, and then if I were to take a y out, this is going to give me 1, followed by positive x squared. 19 is already taken out, so you get a 19 there and you get a y squared there. Now if there is a need to simplify this particular quantity, then we can always do that. Now I would like to use this space that you see here. So what I'm going to do is I'm going to rewrite this negative 1 over 19y, and I'm going to take 19y squared as the LCM. So that would give me 19y squared positive x squared divided by 19y squared. Okay, but x squared positive 19y squared is equal to 19, so I can always replace it there. So this is equal to negative 1 over 19y, and in place of x squared positive 19y squared, I'm going to take it as 19, and then I already have a 19y squared in the denominator, so that would mean the 19 and the 19 can be cancelled, so which is equal to negative 1 over, this is actually y squared, so y squared times 19y will give me 19y raised to the power of 3. So this is my solution, right? So depending on what is required, if you're able to see this to be MCQ choice, you can stop here, or if you want to move it forward until you reach this point, then it's fair enough, you can do that. Students, we are given this question, y is equal to 1 over 36 times secant of 6x. We are expected to find d squared y over dx squared. So as usual, what I would write is differentiating both sides with respect to x, we get. So on the left side it's going to be dy over dx, and on the right hand side 1 over 36 is a constant, so I can take it out. Differentiation of secant x is nothing but secant x tan x. So this is going to give me secant 6x times followed by tan x, so let me write that down, tan of 6x, and then differentiation of 6x. So I can rewrite this as 1 over 36 times secant of 6x times tan of 6x. Differentiation of 6x is going to give me 6, so I can write 6 there. Now 6 divides 36 6 times, so it's going to be 1 over 6 secant 6x tan 6x. Now this is dy over dx, so I'm going to differentiate it twice. So d over dx of dy over dx is equal to, I need to differentiate this, 1 over 6 is a constant, I'm taking it out. This is going to be uv, so d of uv is u times v dash positive v times u dash, right? U times v dash positive v times u dash, the product rule. So I will take secant 6x first and I differentiate tan 6x, then I will take tan 6x and then I will differentiate secant 6x. So this is equal to 1 over 6 times secant 6x, differential of tan x. Now you should know that differentiation of tan x is secant squared x. So this is going to give me secant squared 6x times differentiation of 6x, which is going to be 6. So I'm going to write 6 here. Positive tan of 6x times differentiation of secant x is going to be secant 6x times tan 6x times differentiation of 6x, that's going to be 6.
So I'll write the 6 here. So this is equal to, if I were to bring 6 inside, 6 and 6 will get cancelled, giving me secant 6x times secant squared 6x, that is going to be secant cubed 6x. 6 and 6 gets cancelled, and tan 6x times tan 6x will give me tan squared 6x times secant 6x. Now I can take secant 6x out, that would give me secant 6x here, because secant cubed is here, so secant squared 6x, that's right, positive. I get tan squared 6x, right? Fair enough. So this is my d squared y over dx squared. So unless or until you wanted to simplify this further, right? Students, we are given this question, we are expected to find d squared y over dx squared, given that y is equal to x squared positive 1 divided by root of x. So foremost, what we will do is, as usual, we will be differentiating with respect to x both sides. So when we do that, this is going to give me dy over dx, and this is going to be u over v form. So I'm going to use this formula. D of u over v is v times u dash minus u times v dash divided by v squared. So using this formula, this is going to be root of x times differentiation of x squared is going to be 2 times x, differentiation of 1 is constant, followed by x squared positive 1, differentiation of root of x. Actually, root of x is nothing but x raised to the power of half. So if you were to differentiate this is going to be 1 over 2 times x raised to the power of half negative 1 times differentiation of x, which is 1. So this is going to be 1 over 2 x raised to the power of negative half, which is nothing but 1 over 2 times root of x. So we have already seen it, but just as a refreshment or as a recap, I'm just placing this. So differentiation of root of x would give me 1 over 2 times root of x. So this has to be divided by root of x raised to the power of 2. Now I can rewrite this as 2 times. Now this is x and the root of x. So x times 1 over 2, which is equal to x raised to the power of 1 positive 1 over 2, which is equal to x raised to the power of 3 over 2, right? By the law of indices. So I can rewrite this as 2 times x raised to the power of 3 over 2, negative, I got nothing else to simplify here, so I'll retain it as it is, x squared positive 1 divided by 2 times root of x. The whole is divided by root of x squared. In fact, root of x squared is going to be x, right? Root of x raised to the power of 2 is equal to x. Now I'm going to simplify this by using the mathematical property, which is a positive b divided by c is equal to a over c positive b over c. So by this I can rewrite this as 2 times x raised to the power of 3 over 2 divided by x, negative. So I'm actually flipping it, I'm writing each component by the denominator. So this is going to be x squared positive 1 divided by 2 times root of x times x. Now this is equal to 2 times x raised to the power of 3 over 2. I'm going to push it to the numerator, so that one means this is negative 1 followed by negative x squared positive 1 divided by x raised to the power of 1 over 2 and 1, that's going to give me x raised to the power of 3 over 2. Now this is nothing but 2 times 3 over 2 minus 1, that's going to be 1 over 2. Now I can take this to the numerator, so it's going to be x squared positive 1 divided by 2 times x raised to the power of negative 3 over 2. So this is equal to 2 times x raised to the power of 1 over 2, and this can be rewritten as negative, I'm placing 1 over 2 over here, so x squared times this, which is nothing but 2 negative 3 over 2 positive x raised to the power of negative 3 over 2.
which is equal to 2 times x raised to the power of 1 over 2 negative 1 over 2 times. This is going to be 4 negative 1, which would give me 1 over 2, and this is going to be x raised to the power of negative 3 over 2. So by taking 1 over 2 inside, this is nothing but 2 times x raised to the power of 1 over 2 negative 1 over 2 times x raised to the power of 1 over 2 and negative 1 over 2 times x raised to the power of negative 3 over 2. So in this case I can take x raised to the power of 1 over 2 out. That gives me 2 negative 1 over 2. So this is 1 over 2 times x raised to the power of negative 3 over 2. Now this is going to be 4 negative 1, which is nothing but 3 over 2 x raised to the power of 1 over 2 followed by 1 over 2 times x raised to the power of negative 3 over 2. What is this? This is nothing but my dy over dx. So if we want to operate this by d over dx, that means I need to differentiate this entire term again, right? X raised to the power of 1 over 2 negative 1 over 2 times x raised to the power of negative 3 over 2. This is nothing but 3 over 2 times 1 over 2 times x raised to the power of 1 over 2 negative 1 followed by negative 1 over 2. I differentiate this, I get negative 3 over 2 times x raised to the power of negative 3 over 2 negative 1. This is 3 over 4, 1 over 2 negative 1. That gives me x raised to the power of negative 1 over 2. Negative negative positive 3 over 4. This is negative 3 over 2 negative 1. That's going to be negative 5 over 2. So if I were to take x raised to the power of, in fact I can take 3 over 4 out. I'm going to take 3 over 4 out, and I can take x raised to the power of negative 1 over 2 out. So if I were to take x raised to the power of negative 1 over 2 out, this is going to give me 1 positive x raised to the power of negative I need to get 5 over 2. So 1 over 2, if I were to take 1 over 2 out, so this has to be x raised to the power of negative 2, right? And I'll just show you why it has to be negative 2. Because if I were to multiply x raised to the power of negative 1 over 2 with 1, I get the first term, fine. If I were to multiply x raised to the power of negative 1 over 2 with x raised to the power of minus 2, then this is actually equal to x raised to the power of negative 1 over 2 followed by negative 2, which when I take the LCM I get negative 1, negative 4 over 2, which is negative 5 over 2, which is what is we have started with, right? So this is okay. Now you have to understand that the original equation which we were given with, say we were given with this, right? So from here we can actually rewrite this. See, from here this is nothing but x squared positive 1 is equal to root of x times y. So this is what we have got. So what I want to do is I would like to rewrite this as 3 over 4 times x raised to the power of negative 1 over 2, and then this is going to be 1 positive x raised to the power of negative 2 can be written as 1 over x squared, right? So I can rewrite this as 3 over 4 x raised to the power of negative 1 over 2, and this is going to be x squared positive 1 divided by x squared. So this is what I've got. Now as I mentioned to you, since x squared positive 1 is equal to root of x times y, I can actually replace x squared positive 1 over here. Okay, so let's do that. So this is going to be 3 over 4 x raised to the power of negative 1 over 2. In place of x squared positive 1, I'm going to replace it as root of x times y. Of course there is x squared term here. Now if you want, we can simplify this for the fact that
I got x raised to the power of negative 1 over 2 here. Okay, and then I have to multiply it by 1 over 2. So this is going to be x raised to the power of 1 over 2 plus 1 over 2, which is actually equal to x raised to the power of negative 1 positive 1, right? So that means we are actually getting these two things cancelled, right? These two things are cancelled. So that would leave me with 3 over 4 times y divided by x squared. I know this question is a little bit long, but I need to take some time to make sure that the understanding is obtained in all directions. So I think this is a good place to stop, students. Students, we are expected to find d squared over dx squared of sine inverse of x raised to the power of 3. Now it is imperative to understand what happens when we differentiate sine inverse of x. The formula is 1 over root of 1 negative x squared. This is a very important formula. You will have to remember this. So having obtained this, foremost what we are going to do is we are going to rewrite this as d over dx of sine inverse of x to the power of 3. Now this is equal to d over dx of differentiation of sine inverse of x to the power of 3 is nothing but 1 over root of 1 negative. In place of x you need to substitute x to the power of 3 and take it to the power of 2 times I need to differentiate x to the power of 3. Now this can be rewritten as d over dx of 1 over square root of, now this is nothing but 1 negative x raised to the power of 6 times differentiation of x to the power of 3 is 3 times x squared. So now I've got d over dx of 3 times x squared divided by root of 1 negative x raised to the power of 6. Now we know this quotient rule, right? U over v is nothing but v times u dash minus u times v dash divided by v squared. This is what we know. So I would be using this quotient rule to differentiate this. So this is going to be root of 1 negative x raised to the power of 6. That's my v times the differentiation of this is going to be 3 times of 2 times x negative 3 times x squared. Now differentiation of, say you got y is equal to root of 1 negative x power 6, which is nothing but 1 negative x power 6 raised to the power of half. Now if you want to differentiate this is nothing but 1 over 2 times 1 negative x power 6 raised to the power of 1 over 2 negative 1 times differentiation of 1, which is 0, followed by differentiation of x power 6, which is 6x to the power of 5. So this could be rewritten as negative 6x raised to the power of 5 divided by, this is going to give you negative half, so it's going to be root of 1 negative x power 6. Of course there is a 2 there, you can place it, and then you can take this 2 and divide this, and then you can rewrite it as negative 3 times x raised to the power of 5 divided by square root of 1 negative x raised to the power of 6. Okay, so you can take this and all you need to do is just substitute it there. So this is going to be negative 3 times x raised to the power of 5 divided by square root of 1 negative x power 6. Okay, the entire component is divided by root of 1 negative x power 6 raised to the power of 2. This is what you have got. Now you need to simplify this, which is nothing but 3 times 2 is 6x times root of 1 negative x power 6, negative negative positive, 3 times 3 is 9, x power 2 with x power, you have to know this formula, a raised to the power of m times a raised to the power of n is a raised to the power of m positive n. So if you were to use this formula, this is going to be x raised to the power of 2 positive 5, which is 7 divided by root of 1 negative x raised to the power of 6. So this is what I've got. Of course, this entire thing has to be divided by the 2 and the radical sign gets neutralized, giving me 1 negative x raised to the power of 6. Of course, I can rewrite this as 6x times root of 1 negative x power 6 divided by 1 negative x power 6 followed by positive 9 times x raised to the power of 7 divided by root of 1 negative x power 6 times 1 negative x power 6. So this is what we have got after the rewriting that had been taking place. Now this is the final outcome, but if you want to simplify, you can simplify. So this is equal to 6x. I'm going to rewrite this as 1 negative x power 6 raised to the power of half. Now this is 1, so when it comes to the numerator it becomes negative 1. Positive 9 times x raised to the power of 7. Now this is half and this is 1. So that would mean I get 1 negative x power 6 raised to the power of 3 over 2. Right? So I can further rewrite this as 6x, and this is going to be 1 negative x raised to the power of 6. Half negative 1 will give me negative half followed by 9 times x raised to the power of 7 divided by 1 negative x raised to the power of 6 raised to the power of 3 over 2. If you want, you can bring this down. So that is going to be 6x divided by 1 negative x raised to the power of 6 raised to the power of 1 over 2 followed by a positive 9 x raised to the power of 7 divided by 1 negative x raised to the power of 6 raised to the power of 3 over 2. Now if you want, you can take the LCM and simplify this further. Now just in case if you're not happy with this, you can simplify this by taking 1 negative x raised to the power of 6 raised to the power of 3 over 2 as the LCM. So this would give me 6x times of 1 negative x raised to the power of 6 followed by positive 9x raised to the power of 7. So this is going to be 6x times 1 is 6x followed by 6x raised to the power of 7 positive 9x raised to the power of 7 divided by 1 negative x raised to the power of 6 raised to the power of 3 over 2. So this is going to be, I can add these two things, so that would give me 3x raised to the power of 7 followed by positive 6x divided by 1 negative x raised to the power of 6 raised to the power of 3 over 2. So this is my final solution. So either this or this, so depending on what you want. Of course this is a little bit lengthy, the technique that we have followed. You can adopt simplification right over here. You can take the LCM as root of 1 negative x raised to the power of 6 and simplify it, and then you would be able to reduce one step. But I like to do things in a little bit extensively detailed for rendering understanding, specifically when you are starting off with calculus. So the more the steps present, the better the understanding of the subject. Students were expected to obtain the double differential of 1 over 1 positive cos x. Now this is a very standard question, so that's the reason I'm doing this. So foremost, what we would do is we would rewrite this as d over dx of 1 over 1 positive cos x, right? Now what I wish to do is you can either apply u over v form. So let us just check that out. So I'm going to take my u as 1 and my v as 1 positive cos x. So my u dash is going to be 0 and my v dash is going to be negative sin x.
So my formula d of u over v is v times u dash minus u times v dash divided by v squared. So this is equal to d over dx of 1 positive cos x times differential of 1, which is 0, negative 1 times differential of 1 positive cos x is negative sin x, divided by 1 positive cos x raised to the power of 2. So this one will vanish, negative, negative, positive. So I now have d over dx of sin x over 1 positive cos x raised to the power of 2. So this is what I've got. Now I'm going to take, this is my first assignment which I have successfully completed. Now I will just go on to obtain the next differential. So my u is sin x and my v is 1 positive cos x raised to the power of 2. So my u dash will be cos x, my v dash is 2 times of 1 positive cos x raised to the power of 2 minus 1, that's 1 times differential of 1 positive cos x. This can be rewritten as 2 times of 1 positive cos x times differentiation of 1 is 0, differentiation of cos x is negative sin x. This I can rewrite it as 2 times of sin x, the negative sign, times 1 positive cos x. This is my v dash. So this is my second assignment. So what we are going to do, we are going to apply u over v form. That's going to be 1 positive cos x raised to the power of 2. Differentiation of sin x is cos x, negative sin x times differentiation of 1 positive cos x raised to the power of 2. That's going to be negative 2 times sin x times 1 positive cos x divided by 1 positive cos x. This is my v, this has to be raised to the power of 2. Okay, so this is equal to, I'm rewriting this one more time, 1 positive cos x raised to the power of 2 times cos x, negative, negative, positive, 2 times sin x, sin x gives me 2 times sin squared x times 1 positive cos x divided by 1 positive cos x raised to the power of 2, which is raised to the power of 2. 1 positive cos x raised to the power of 2, 1 positive cos x. I can always take 1 positive cos x out. If I do that, I would have 1 positive cos x times cos x positive. This is 2 here, right? So this is going to be 2 times sin squared x. So we would have to divide by 1 positive cos x raised to the power of 2 raised to the power of 2. So now if you see the denominator, this is 1 positive cos x raised to the power of 2, the whole raised to the power of 2. So that's actually 4. Now you got 1 positive cos x. So I can just get rid of 1 positive cos x in the numerator, giving me 1, say I can just remove this parenthesis. So cos x times 1, that's going to be cos x plus cos squared x plus 2 times sin squared x divided by, as I mentioned to you, 1 positive cos x can be neutralized with 1 positive cos x raised to the power of 4. So in the denominator I got 1 positive cos x raised to the power of 3. So this is a good place to stop. And what is this? This is my double derivative. Okay, so this is my d squared over dx squared of 1 over 1 positive cos x. So thank you students, we will continue again. we would be employing the formula, the product rule, which is going to be u times v dash positive v times u dash. So if I were to take u to be as x squared, my u dash is going to be 2 times x, and my v to be as tan inverse of x, then my v dash is 1 over 1 positive x squared. So I'm going to rewrite this as d over dx of x squared times tan inverse of x, and I will apply the uv formula. So it's going to be u times differential of tan inverse of x, 1 over 1 positive x squared, positive tan inverse of x times differential of x squared is going to be 2x. I can rewrite this as d over dx of x squared divided by 1 positive x squared, positive 2x times tan inverse of x. Now this is nothing but d over dx of x squared divided by 1 positive x squared, positive 2 times d over dx of x times tan inverse of x. So this is u over v formula. So the quotient rule, if we were to apply, d of u over v is v times u dash minus u times v dash divided by v squared. So this is going to be 1 positive x squared times differential of x squared is 2x, positive x squared followed by negative x squared times differential of 1 positive x squared will give me 2x divided by 1 positive x squared raised to the power of 2. So this is one part followed by 2 times of product rule. So differentiation of x times tan inverse of x is x times 1 over 1 positive x squared, positive tan inverse of x times differential of x, that's 1. So if I were to rewrite this, this is going to be 2x divided by 1 positive x squared raised to the power of 2. Probably I can simplify this first. So 2x times 1, positive 2x to the power of 3, negative 2x to the power of 3, this is one part, positive 2 times x divided by 1 positive x squared, positive 2 times tan inverse of x. Now this is equal to 2x cubed, negative 2x cubed gets cancelled, giving you 2x over 1 positive x squared raised to the power of 2, positive 2x divided by 1 positive x squared, positive 2 times tan inverse of x. Now if I were to take the LCM as 1 positive x squared raised to the power of 2 for this part, for these two parts, this is going to give me 2x, positive 2x times 1 positive x squared, positive 2 times tan inverse of x. So this is equal to 2x, positive 2x, positive 2x cubed divided by 1 positive x squared raised to the power of 2, positive 2 times tan inverse of x. Now these two can be added, which is 4x, positive 2x cubed divided by 1 positive x squared raised to the power of 2, positive 2 times tan inverse of x. So probably if I were to take x out, if I were to take a 2 out and a x out, this is going to give me, say, 2x, positive, in fact I have already taken a x out, so I have to rewrite this as 2 times x out. So this is going to be 2 times 2, 4x, positive, this is going to be x squared, right? So 2x times x squared will give you 2x cubed. So I think we would not be able to simplify it any further, right? So I was under the impression that we would be able to simplify it, but the simplification is not much. So I think we can stop here. I think this is the right place to stop for this particular question. So we are expected to find d squared y over dx squared for this question. So foremost we would be differentiating with respect to x both sides. So when we do that, we get dy over dx is equal to, this is actually uv formula, which is u times v dash positive v times u dash. So x to the power of 5 times differential of ln x, which is 1 over x, positive ln x times differential of x power 5, which is 5 times x to the power of 4. I can rewrite this x power 4 positive 5 times x power 4 times ln x. So this is my dy over dx. Now I need to find d over dx of dy over dx, which is nothing but d over dx of x to the power of 4 positive 5 times x power 4 ln x. This can be rewritten as d over dx of x power 4 positive 5 times d over dx of x power 4 ln x by linear property present in differentiation. So d over dx of x to the power of 4 is 4 times x to the power of 3 positive 5 times u over v form. So x power 4 times differentiation of ln x is 1 over x, positive ln x times differential of x power 4 is 4 times x to the power of 3. I can rewrite this as 4 times x power 3 positive 5 times x to the power of 4 and x. So this is x to the power of 3 positive 5 times, I'm going to write this as 4 times x power 3 times ln x. However, we can still further rewrite this in this fashion by adding 4 with 5, that's going to be 9. You get x power 3 positive 4 times 5 is 20 x to the power of 3 ln x. We can take x power 3 out and rewrite this as 9 positive 20 times ln x. This is my d squared y over dx squared. So that is the solution. So we can move on to the next question. Students, we are expected to obtain the differentiation, double differentiation of e raised to the power of x squared. So I'm going to rewrite this as d over dx of d over dx of e raised to the power of x squared. Now this is nothing but d over dx. When I differentiate e raised to the power x squared, is going to be e raised to the power x squared multiplied with the differentiation of x squared. This can be rewritten as d over dx of e raised to the power of x squared times differentiation of x squared would give me 2x. So now I can apply u over v, u times v formula. So this is e raised to the power of x squared times x, which is equal to 2 times of u into v. So e raised to the power of x squared times differentiation of v, which is x positive x times differentiation of e raised to the power of x squared is e raised to the power of x squared times differentiation of x squared. So this is equal to 2 times of e raised to the power of x squared positive x times e raised to the power of x squared times differentiation of x squared will give me 2x. So this could be further rewritten as 2 times e raised to the power of x squared positive 2 times x into x is x squared e raised to the power of x squared, right? So if you want to remove the parenthesis, in fact you can take e raised to the power of x squared out. If you were to take e raised to the power of x squared out, you get 1 and then positive 2 times and then you get an x squared. So I think this is the right place to stop by taking e raised to the power of x squared out. So that gives us a better way of representing the solution. So that completes. Students were expected to find the double differential of sine of ln x. I'm going to rewrite this as d over dx of d over dx of sine of ln x. This is equal to d over dx. Differentiation of sine is cos, and then we will have to differentiate ln x. So this is equal to d over dx of cos ln x times differential of ln x is 1 over x. I can rewrite this as d over dx of cos of ln x divided by x. this is nothing but u over v form, which is v times u dash minus u times v dash by v squared. So I'm going to use that form, quotient rule. So x times differential of cos is negative sine of ln x times differential of ln x. So this is my one term. So v into u dash minus my u into v dash. So differential of x is going to be 1 divided by v squared, it's x squared. So if I were to rewrite this is going to be x times of negative sine of ln x. Differential of ln x is 1 over x, so I'm going to place the x here, followed by negative cos of ln x divided by x squared. Now if I were to remove this x and x, so I will get negative sine of ln x, negative cos of ln x divided by x squared. You can either stop here or take the negative sign out and rewrite this as sine of ln x positive cos of ln x divided by x squared. So this is nothing but d squared over dx squared of sine of ln x. So this is my final solution to the question. Students, we are expected to find the double differential of ln of sine x. I'm going to rewrite this as d over dx or d over dx of ln of sine x. So when I differentiate this quantity, this is going to be 1 over sine x times differential of sine x, which is equal to d over dx of, now differentiation of sine x is going to be cos x divided by sine x, which is nothing but d over dx. You can either just retain it as cos x over sine x, or you can just say it as cot x, right? Now differential of cot x is negative cosecant squared x. So that is the solution for d squared over dx squared of ln of sine x. Now just having obtained this, I'm going to show you what happens if you got d squared over dx squared of ln of cos x. Now this is equal to d over dx of d over dx of ln of cos x. So this is nothing but d over dx of differentiation of ln of cos x is 1 over cos x times differentiation of cos x. So this is equal to d over dx of, now differentiation of cos x will give me negative sin x. I got a cos x here. So this is nothing but, I'm taking a negative sign out, so d over dx of tan x. Now differentiation of tan x is secant squared x, so this is what you get. So we're expected to find d over dx of root of 1 negative x squared positive x times sine inverse of x. I will try to finish off this particular question within this space. I'm going to rewrite this as d over dx of root of 1 negative x squared positive d over dx of x times sine inverse of x. Now differentiation of this is going to be, now before that let me rewrite this as d over dx of 1 negative x squared raised to the power of 1 over 2 positive d over dx of x times sine inverse of x. So differential of this is going to be 1 over 2 times 1 negative x squared times 1 over 2 minus 1, that's going to be negative half, times differentiation of 1 negative x squared. Positive, this is UV formula. So we need to apply the product rule. So d of u times v is u times v dash positive v times u dash. So this is going to be x times sine inverse of x differential is root of 1 negative x squared positive sine inverse of x times differential of x is 1. Now this is equal to 1 over 2 times, I can push this 1 negative x squared raised to the power of negative half as 1 negative x squared with a root, and differential of 1 is 0, differential of negative x squared will give me negative 2 times x, positive x times root of 1 negative x squared positive sine inverse of x. This is a 2 and a 2 can be cancelled, giving me negative x over root of 1 negative x squared positive x times root of 1 negative x squared positive sine inverse of x, negative x over root of 1 negative x squared positive x root of 1 negative x squared, they both can be cancelled, giving me sine inverse of x. So this is the final answer to this question. Students, we are expected to differentiate x squared times root of 5 negative x squared. So I'm going to rewrite this as d over dx of x squared times 5 negative x squared raised to the power of 1 over 2. I'm going to apply UV method. So my UV method is d of UV is u times v dash positive v times u dash. So by this formula is going to be x squared times differential of this entire quantity will give me 1 over 2 times 5 negative x squared raised to the power of 1 over 2 negative 1 times differentiation of 5 negative x squared. So this is for the first term positive. I need to have the differentiation for x squared. So it's going to be 5 negative x squared raised to the power of 1 over 2 times differential of x squared is going to be 2x. So rewriting this, I get x squared times 5 negative x squared raised to the power of negative half, differentiation of 5 is 0, followed by differentiation of x squared will give me negative 2x, there is a 2 there, followed by positive 5 negative x squared raised to the power of 1 over 2 times differentiation times 2x, we have already differentiated x squared. So I can rewrite this, of course I can take this 2 out, so this is going to be negative x squared into x is going to be x to the power of 3. I'm going to push this down, so it's going to be root of 5 negative x squared positive 2 times x square root of 5 negative x squared. So this is what I've got. If you want, you can take the LCM as root of 5 negative x squared and rewrite this as negative x cubed followed by 2x times this is going to give me 5 negative x squared, which is negative x to the power of 3 positive 10x negative 2 times x to the power of 3 divided by root of 5 negative x squared. 2 x cubed with a negative sign can be added with negative x cubed, that's going to give me negative 3 times x cubed positive 10x divided by root of 5 negative x squared. So this is what I have got. Now moving on, problem number 65, let us try to obtain the differential of x times root of 4 negative x squared. So this is going to be d over dx of x times, I'm going to rewrite this as 4 negative x squared raised to the power of half. I'm going to apply the product rule, so that's going to be x times of differential of this, that's going to be 1 over 2 times 4 negative x squared raised to the power of negative half times differentiation of 4 negative x squared. So this is for the one part, positive 4 negative x squared raised to the power of 1 over 2 times differentiation of x, that's going to give me 1. So if I were to rewrite this, this is going to be x times, in fact I can push this guy down, so this is going to be 2 times root of 4 negative x squared. Differentiation of 4 is 0. Differentiation of negative x squared will give me negative 2 times x followed by a positive sign root of 4 negative x squared. A 2 and a 2 can be cancelled. X into x will give me x squared. Of course there is a negative sign there, divided by root of 4 negative x squared, positive root of 4 negative x squared. If I were to take the LCM as root of 4 negative x squared, this would give me x squared, this would give me 4 negative x squared. I add these two, I get negative 2 times x squared positive 4 divided by root of 4 negative x squared. If you want, you can take 2 out. If you take 2 out, you would get 2 negative x squared divided, because 2 times 2 is 4, that's fine. 2 times negative x squared is negative 2x squared divided by root of 4 negative x squared. So this is one side of the solution for this question, and this is the other solution for this question 64. So we have done 2 questions, so we'll move on to the next one. Students, we are expected to obtain the differentiation of root of x squared negative 1 divided by x squared. So I would be applying the quotient rule, which is d of u over v is equal to v times u dash minus u times v dash divided by v squared. So this is what is the quotient rule. So this is nothing but x squared times. Now before we could do that, let me rewrite this question to be as d over dx of x squared negative 1 raised to the power of 1 over 2 divided by x squared, right? So differentiation of this is going to give me 1 over 2 times x squared negative 1 raised to the power of 1 over 2 negative 1 times differentiation of x squared negative 1. So that's one side, negative root of x squared negative 1, differentiation of my v, that's going to give me 2x. The entire thing has to be divided by x squared raised to the power of 2. Now I can rewrite this as x squared. I can push this guy down because it's going to be negative half. So it's going to be x squared divided by 2 times root of x squared negative half. That's fine. Differentiation of x squared is 2 times x. Differentiation of 1 is 0. So you get a negative sign, 2 times x, square root of x squared negative 1. This entire thing has to be divided by x to the power of 4. Now a 2 and a 2 can be cancelled. X squared times x will give me x to the power of 3 divided by root of x squared negative 1 followed by 2 times x root of x squared negative 1. This entire thing has to be divided by x to the power of 4. Now I'm going to take the LCM as root of x squared negative 1. Of course there is a divisor here, so I will handle this divisor later. If you want, you can flip it up, but I will just retain it as it is. I will just retain this x to the power of 4 as it is. So first let me resolve this quantity. So this is going to give me x to the power of 3 negative 2 times x followed by x squared negative 1. Now this is equal to x to the power of 3 negative 2x times x squared will give me 2x to the power of 3 negative 1 divided by root of x squared negative 1. So now I can flip it. If I flip it and bring it out, it will be x to the power of 4 over here. Now negative 2x cubed with x cubed can be added, giving me negative x cubed followed by a negative sign divided by, in fact 2x times x squared, that's fine, 2x cubed, negative 2x times negative 1, that's going to be positive 2x, so I need to have a positive 2x there. So this is fine, negative x cubed followed by positive 2 times x times x to the power of 4 times root of x squared negative 1. So that is fine. Now if I were to take x out, no it's not, if I were to take a x out, maybe I can simplify something. So I'm taking a x out, so that's going to give me 2 negative x squared for this quantity, because x into 2 gives me positive 2x, and then x into x squared gives me negative x cubed divided by x to the power of 4 times root of x squared negative 1. X and x can be cancelled, giving me 2 negative x squared divided by x to the power of 3 square root of x squared negative 1. So this is my solution to the question that we have started with. So this is the question and this is the solution. Students were expected to differentiate x over root of x squared negative 1. I will try to squeeze this in this space here. So as usual, what we will do is we will apply the quotient rule d of u over v, which is v times u dash minus u times v dash divided by v squared. So by this quotient rule, this is going to be, I'm going to rewrite this first as d over dx of x over x squared negative 1 raised to the power of half. Okay, so this is going to be, if I want to differentiate, or in other words apply u over v form, first I will start off in this fashion. So x squared negative 1 with a square root sign times differentiation of x is going to be 1 negative x times, I need to differentiate this, so this is going to be 1 over 2 times x squared negative 1 raised to the power of 1 over 2 negative 1 times differentiation of x squared negative 1 divided by x squared negative 1. I got a 1 over 2 there and I have to square this. Now this one can be rewritten as root of x squared negative 1 followed by negative x. I can push this guy down because it's going to be negative half. So x over 2 times root of x squared negative 1, this is going to give me 2x, and that is divided by a 2 and a 2 can be cancelled, giving me x squared negative 1. Now clearly this 2 can be cancelled and I would be left with root of x squared negative 1 negative, since this 2 and 2 gets cancelled and I get x squared. So what I would do is I will just take the LCM as root of x squared negative 1. I know there is a quantity x squared negative 1. I will write that down like this. If I were to take the LCM, I would get x squared negative 1. Over here it's going to be negative x squared. Clearly positive x squared negative x squared gets cancelled. Now if I were to flip this, this is going to be equal to negative 1 divided by root of x raised to the power of 2 negative 1, and that has to be multiplied with x squared minus 1. Now this is exponent 1 and this is 1 over 2. So this is going to be negative 1, right? Negative 1 divided by, now 1 over 2 added with 1 would give me 3 over 2, right? So that is exactly what's going to occur here. So this is going to be x squared negative 1 raised to the power of 3 over 2. So this would be our final solution for this question. So let me draw the line. Now question number 67, I just want to use this particular space and get the answer. Now we are expected to differentiate d over dx of cos of sine inverse of x. So this is going to be differential of cos x. So what is the differential of cos x? If someone is asking you what is the differentiation of cos x, what would you say? It's going to be negative sine x. That is exactly what you have to write here. So this is going to be negative sine of, this is the x, so it's sine inverse of x, right, times differentiation of sine inverse of x. So this is going to be equal to negative sine of sine inverse of x times differential of sine inverse of x. What is that? 1 over root of 1 negative x squared. Now sine and sine inverse can be cancelled, giving me negative x over root of 1 negative x squared. This is a very important result and you will have to take note of this particular solution. So So we move on to the next question, students. So we are expected to find the differentiation of ln of 3x cubed positive 2x squared positive x positive 2, and we know that differentiation of ln x is nothing but 1 over x. So this is a very important property we have to apply here. So we'll start off with the differentiation. So this is going to be 1 over 3x to the power of 3 positive 2x squared positive x positive 2 times differentiation of this entire quantity 3x to the power of 3 positive 2x squared positive x positive 2, which is going to be equal to differential of 3x cubed is going to be 3 times of 3 raised to the power of 3 minus 1, that's going to be 2 here, positive 2 times of 2x, right, and this is going to give me 1. Of course 2 is going to be 0, divided by 3 times x to the power of 3 positive 2 times x squared positive x positive 2. I can rewrite this as 3 times 3 is 9x squared positive 4x positive 1, divided by 3 times x cubed positive 2x squared positive x positive 2, which is the final solution for the question. Students, we are given this question. We are expected to differentiate tan inverse of 5x. This entire quantity is raised to the power of 3. So you have to visualize this like this. So the visualization is something of this nature. So you have given x to the power of 2 negative 2x, and this is raised to the power of 3. So you will have to differentiate a quantity of this fashion. So that means first the degree comes down, and then there is a reduction in the degree, followed by the differentiation of each of these terms. So that is the way you will have to do this question, because this is tan inverse of 5x. So this is the major part of the question, right? And this quantity is in turn raised to the power of 3. So just as I mentioned to you, you will have to view it in this fashion. So if you start to differentiate, this is going to be 3 times of this major quantity tan inverse of 5x, and the degree gets reduced, so it's going to be 3 negative 1 times differentiation of tan inverse of x. Now what is differentiation of tan inverse of x? Now tan inverse of x differentiation is 1 over 1 positive x squared. We know this. So that's going to be 1 over 1 positive, in place of x squared we got 5x raised to the power of 2 times differentiation of 5x. What is that? 5. So this is the final solution. However, we can rewrite it. We got to do that. So this is going to be 3 times tan inverse of 5x, and that is raised to the power of 2, divided by 1 positive 5x raised to the power of 2 is going to be 25x squared. There's a 5 there. Of course I could have multiplied that 5 with 3 and rewrite 10 as 15. So this is my final solution, and I can draw the beautiful red line. Okay, question number 71. Probably I can use a space here. D over dx of third root of x to the power of 3. Now this can be rewritten as d over dx of x to the power of 3. Now third root, this is going to be this entire component raised to the power of 1 over 3. Then by the law of indices I can cancel the powers, the 3 and 1 over 3, and that is going to be d over dx of x. So differentiation of x is going to give me 1. So that is the solution to this question.
Students, were expected to find the differentiation of sine of x squared times ln of x. Now differentiation of sine, we know it is cos, so I'm going to write this as cos of x squared times ln x times differentiation of x squared times ln x. So this can be further rewritten as cos of x squared times ln x. Now this is UV formula.
right? So it's going to be x squared times the differentiation of ln x is 1 over x, positive ln x times differentiation of x squared is going to be 2 times x. So I can further rewrite this as cancelling x and x. This is going to be cos of x squared times ln x, and then you've got, since x and x are cancelled, I get an x remaining there, positive 2x, so I can rewrite this as 2x times ln x. Now I can further rewrite this as x times cos of x squared times ln x, positive 2x times ln x times cos of x squared times ln x. This is a good place to stop, and I'll draw the red line here. Students were expected to differentiate cosecant of x cubed. Now before we could obtain the differentiation, it is imperative we know what is differentiation of cosecant x, which is nothing but negative cosecant x times cot x. So I will box this result up. So differentiating cosecant of x cubed would give me negative cosecant of x cubed times cot of x cubed times differentiation of x cubed. This is rewritten as negative cosecant of x cubed times cot of x cubed times differentiation of x cubed will give me 3 times x squared. I can rewrite this as negative 3 times x squared times cosecant of x cubed times cot of x cubed. So this is going to be my final solution to this question. Students were expected to differentiate x cubed negative 1 over ln of x squared. So I will be using this formula d of u over v, which is v times u dash minus u times v dash divided by v squared. So by this formula, this is going to be ln of x squared times differentiation of x cubed negative 1, that's 3x squared negative x to the power of 3 negative 1 times differentiation of ln x squared, that's 1 over x squared times differentiating x squared, which is 2 times x, divided by ln of x squared raised to the power of 2. Now I can rewrite this as 3 times x squared times ln of x squared negative x to the power of 3 negative 1. Now I can cancel a x and a x here, so there is a 2 there divided by an x, and then I have got ln of x squared raised to the power of 2. Now if I were to take the LCM, this is going to give me 3 times x to the power of 3 ln of x squared negative 2 times of x cubed negative 1 divided by x. So if I were to flip this, this is going to give me ln of x squared raised to the power of 2. Now I cannot do any much simplification over here, so the best thing would be to just stop at this particular point, because even if I were to remove the parenthesis, I wouldn't be able to do any such reductions. So this is the best place to stop for this question. Students were expected to differentiate 20 raised to the power of x. Now what I wish to do is I would like to draw your attention to this all important formula. Now e raised to the power of ln 20 is nothing but 20, because e and ln gets cancelled. So similarly, e raised to the power of ln 20 raised to the power of x is nothing but 20 raised to the power of x. So this is a very important deduction that you will have to know. So 20 power x can be rewritten as, so this is equal to d over dx of e raised to the power of ln 20 raised to the power of x. So I can very well do that. Now we know that ln of a raised to the power of b is equal to b times ln a. So by this I can rewrite this as d over dx of, this is e raised to the power of x times ln 20. Now this is similar to, say, you are given y is equal to e raised to the power of 2x, right? So 2 in this case is nothing but ln 20. So if you were to ask to find dy over dx in this case, you're going to say this is nothing but e raised to the power of 2x, the coefficient of x is 2, so you're going to write it like this, that's it, right? So similarly, if you were to differentiate this, this is going to be e raised to the power of x times ln 20, the coefficient of x is ln 20, so you write here as ln 20. However, if you want, you can always push this x over here to 20 and rewrite this as e raised to the power of ln 20 raised to the power of x times ln 20. In fact, e and ln will be neutralized, so that would give you 20 raised to the power of x times ln 20. So this is another variation to this question. So depending on what is the requirement, you can suitably obtain that. Students, we are expected to differentiate fourth root of x squared positive ln x raised to the power of 3. So I would like to rewrite this as d over dx of x squared positive ln x raised to the power of 3. This entire quantity is raised to the power of 1 over 4. Now when we differentiate, we would get 1 over 4 times x squared positive ln x raised to the power of 3, and that is raised to the power of 1 over 4 negative 1 times differentiation of x squared positive ln x raised to the power of 3. Now this is equal to 1 over 4 times x squared positive ln x raised to the power of 3, 1 over 4 negative 1. So you got something like this. So this is nothing but 1 negative 4 over 4, which is negative 3 over 4. So this is negative 3 over 4 times differential of x squared is 2x, differential of ln of x raised to the power of 3. This is going to be 3 times of ln x raised to the power of 3 negative 1 times differentiation of ln x, which is nothing but 1 over x. So this is what you've got. I can very well rewrite this as this is equal to 1 over 4 times x squared plus ln x raised to the power of 3. This is raised to the power of negative 3 over 4 times 2x positive 3 over x times ln x raised to the power of 2. I can further rewrite this as 2x positive 3 over x times ln x raised to the power of 2, right? So I need to bring this guy down. So if I were to bring this guy down, this is going to be 1 over x squared plus ln x raised to the power of 3. This entire thing is raised to the power of 3 over 4. Positive 3 over 4, you got a 4 there. Now you can either stop here. Probably you can rewrite this as, in fact, if you were to take the LCM, this is 2x squared positive 3 times ln x raised to the power of 2, right, divided by x, and then you got a 4 there, and then this quantity, I'm going to write this quantity as x squared positive ln x raised to the power of 3. I'm going to write it like this, 3, and this entire thing is raised to the power of 1 over 4. So finally, if you want to write this again, let me use this space here. So this is equal to 2x squared plus 3 times ln x raised to the power of 2 divided by 4 times of x. This entire thing is fourth root of x squared plus ln x raised to the power of 3, and that has to be raised to the power of 3. Okay, so this is the final solution, and I think we can draw the line.
Students, we are given this question. We are expected to find the differentiation of x raised to the power of 5 over 7 followed by a negative sign and 3 times x raised to the power of 1 over 7. By linear property present in differentiation, I would write this as d over dx of x raised to the power of 5 over 7 followed by a negative sign and 3 times d over dx of x raised to the power of 1 over 7. Now we will use this particular differentiation law. Differentiating x to the power of n will give us n times x raised to the power of n negative 1. So by this property, this is going to be 5 over 7 times x raised to the power of 5 over 7 negative 1 followed by a negative sign and 3 times differentiating x raised to the power of 1 over 7 will give me 1 over 7 times x raised to the power of 1 over 7 negative 1. So this is equal to 5 over 7 times x raised to the power of 5 over 7 negative 1. That's going to give me negative 2 over 7 followed by negative 3 over 7, and then x raised to the power of 1 over 7 negative 1. That's going to be negative 6 over 7. I can rewrite this by taking 1 over 7 out, and then this is going to be 5 times x raised to the power of negative 2 over 7, and then negative 3 times x raised to the power of negative 6 over 7. I can further rewrite this as 1 over 7 times 5 over x raised to the power of 2 over 7 negative 3 over x raised to the power of 6 over 7. So I can have it like this. Now I can take an LCM for this. So this is going to be x raised to the power of 6 over 7. Now this is going to be 5 times x raised to the power of 4 over 7, because x raised to the power of 2 over 7 with x raised to the power of 4 over 7 would give me x raised to the power of 6 over 7 followed by negative 3 times. So this is what I've got. Now this can be further rewritten as 5 times. Now I can write this x raised to the power of 4 over 7 as x raised to the power of 4. This entire thing raised to the power of 1 over 7 followed by negative 3. Similarly, this can be written as x raised to the power of 6 raised to the power of 1 over 7. Of course, I got a 7 here. I'm going to place that 7 in this fashion. This can be further rewritten as 5 times. This is 7th root of x to the power of 4 followed by minus 3 divided by 7 times 7th root of x raised to the power of 6. So this is a good place to stop, and let me draw the red line. So this is a beautiful question, students. I hope you understood this. Students, we are expected to differentiate log x times root of 1 positive x cubed to the base 3. Now we will have to convert this into natural logarithm. So we have got, imagine something of this fashion, say log x to the base 3. Now we can rewrite this using natural logarithm as log n, because the base is e here and x has to feature that, divided by ln of 3 to the base e. So this is how we need to write if we have to convert this into natural logarithm. So this law is called as the change of base. So having known this, I'm going to rewrite this as d over dx of ln
of x times root of 1 positive x cubed divided by ln 3. The base over here is e. So we are going to use this formula. D of u over v is v times u dash minus u times v dash divided by v squared. So by this formula I can rewrite this as ln 3 times differential of this entire quantity. That's going to be 1 over x times root of 1 positive x cubed times differentiation of x times square root of 1 positive x cubed. Okay, so this is for the first quantity, and negative ln of x times root of 1 positive x cubed. Differential of a constant will give me 0. This entire thing has to be divided by ln 3 raised to the power of 2. Now I can rewrite this as ln 3 of differentiation of x times root of 1 positive x cubed. For this I am going to use uv method, which is u times v dash positive v times u dash. So by this law, this is going to be x times differential of 1 positive x cubed raised to the power of 1 over 2 is 1 over 2 times 1 positive x cubed raised to the power of 1 over 2 negative 1 times differential of 1 is 0, differential of x cubed is 3 times x squared. So this is for my u times v dash, okay, plus differential of x is 1, so it's going to be root of 1 positive x cubed. So this is what we get for differentiating this one. This has to be product multiplied by x into root of 1 positive x cubed. This entire thing is 0, so I can rewrite this with ln 3 raised to the power of 2. So this is what I've got. Now clearly I can cancel a ln 3 and a ln 3, and then I can I cancel anything? Okay, so x squared into x, this is going to give me 3 times x to the power of 3. I got a 2 there. I can bring this 1 positive x cubed raised to the power of negative half down. So this is going to be root of 1 positive x cubed. There's a 2 there. I'll place it, because the degree here is negative 1 over 2, right? Because 1 over 2 minus 1 would give you negative 1 over 2. So that is about it. Positive root of 1 positive x cubed. So this is what we have got for this numerator, divided by, this is x times root of 1 positive x cubed times ln 3. Now I can simplify this. So this is going to give me 3 times x cubed. Root of 1 positive x cubed times 1 positive x cubed, that's going to give me 1 positive x cubed, divided by 2 times root of 1 positive x cubed. There's already a x here, and a root of 1 positive x cubed, and ln 3. So I can rewrite this by adding, is going to be 4 times x cubed positive 1. Root of 1 positive x cubed times root of 1 positive x cubed will give me 1 positive x cubed, and there is a 2, there is a x, I place it, and there is a ln 3, right? So this is what we can do. We can't take anything out, and this is the furthest point we can go. So that's a good place to draw the red line. So this is a beautiful question which we have worked out. We will move on to the next question, students. Students, we are expected to obtain the differentiation of x squared negative 1 over x squared negative x positive 1. So as usual, I will be using u over v method, which is nothing but v times u dash minus u times v dash divided by v squared. So using this formula, this can be rewritten as, applying the differentiation, so it's going to be x squared negative x positive 1 times differentiation of x squared negative 1 will give me 2x followed by x squared negative 1 times differentiation of x squared 2x negative, differentiation of x is going to be 1. So I'll place 1 there. Divided by x squared negative x positive 1. So this can be further rewritten as, probably we can distribute the quantities. So 2x times x squared will give me 2 times x to the power of 3 negative 2x squared positive 2x, and then followed by a negative sign. So I'll distribute x with 2x squared, so it's going to be negative 2x to the power of 3. X squared with negative 1 and a negative sign will be positive x squared. Negative 1 times 2x and a negative 1 will be positive 2x. Negative 1 times negative 1 is positive 1 and a negative sign. So this is divided by x squared negative x positive 1. So we will have to simplify this. Now clearly we can see that x2x cubed negative 2x cubed can be cancelled. And is there anything else? So probably negative 2x squared added with x squared. So that's going to give me negative x squared. And 2x added with 2x, that's going to be 4x. And followed by negative 1 divided by x squared negative x positive 1. So this is what we have got. Of course, we will have to square the quantity because of v squared. So let me place the square there. So we can draw the red line here, and this is a good place to stop. We'll move on to the next question. Students, we are expected to differentiate 1 over 3 times sine cubed x negative sine x. So I will start out by rewriting this as d over dx of 1 over 3 times sine cubed x followed by d over dx of sine x. Now this can be further rewritten as 1 over 3 times. I'm going to differentiate sine cubed x followed by differentiation of sine x. This can be further rewritten as differentiation of sine cubed x is 3 times sine raised to the power of 3 negative 1 x times differentiation of sine x, that's going to be cos x, followed by differentiation of sine x, which is nothing but cos x. I can rewrite this by first cancelling the 3 that I've got, and then this is sine squared x times cos x negative cos x. I can take the cos x out. This would give me sine squared x negative 1. If I were to take a negative sign out, this would give me negative sine squared x positive 1, because negative times negative will be positive, and I need to have a positive sign because negative times positive should give me negative. So further I can rewrite it as negative cos x times 1 negative sine squared x. But what is 1 negative sine squared x? 1 negative sine squared x is nothing but cos squared x. So this is nothing but negative cos cubed x. So this is a good place to draw the red line. Students, we are expected to differentiate e raised to the power of x times sine x. So it is imperative to know that differentiation of e raised to the power of x will give us e raised to the power of x. Actually what is happening is we are actually differentiating e raised to the power of x. Along with that we are differentiating the quantity x, but we are not showing it. Actually differential of x is actually 1, but we are not explicitly writing it. We are simply saying that differentiation of e power x is actually e power x. But behind the scenes, the untold story is that we are actually performing the differentiation of x. So that is a very important point which you will learn from this question. So if I were to apply the differentiation, this is going to give me e raised to the power of x times sine x. Fine. That has to be multiplied with differentiation of x times sine x. So this is
the most important point which you have to focus on. So this is equal to e raised to the power of x times sine x times, I'm going to apply UV formula. So what is my UV formula? This is the product rule, which is nothing but u times v dash positive v times u dash. So applying the product rule, this is going to be x times differential of sine x is cos x, positive sine x times differential of x is 1. So if you were to rewrite this is going to be e raised to the power of x times sine x times cos x positive sine x. So either you can stop here or you can distribute the quantity e raised to the power of x times sine x all through. I think this is the right place to stop. So this is the solution to this question. Students were expected to differentiate square root of x negative x times square root of x positive x. Now I wish to draw your attention to this formula a negative b times a positive b. Using this formula, the outcome is going to be a squared negative b squared. So if I were to be given root of x negative x has to be multiplied with root of x positive x, this is going to be root of x raised to the power of 2 negative x raised to the power of 2. Square root of x raised to the power of 2 would give me x raised to the power of 2 would give me x squared. So this is what I've got here. Now what I wish to do is, instead of this, I would be substituting the term that I've got. What did I get? I get x negative x squared. Now by linear property, this is going to be d over dx of x negative d over dx of x squared. So if I were to perform the differentiation of x, I would get 1. If I were to perform the differentiation of x squared, I will get negative 2x. So the sign between them is negative or minus. So this would be the outcome, and this is a good place for us to draw the red line. Students were expected to find the derivative of cot inverse of 1 over x squared. Now before we could obtain the derivative of cot inverse of 1 over x squared, I would like to show you what is the derivative of cot inverse of x. This is a very valid question. Now you can search the answers for this particular question, but most of the solutions that you would come across wouldn't be straightforward. So that is the reason I have chosen to present the solution here. Now foremost, let us assume that we are expected to find the derivative dy over dx for cot inverse of x. Now if I were to move this cot inverse to the left side, I would get cot of y is equal to x. So this is fair enough, right? So now what I wish to do is, I would like to differentiate both sides with respect to x. So if I were to differentiate this, what do I get? Differential of cot is going to be negative cosecant squared y times differential of y, which is dy over dx, and differentiation of x will give me 1. Now let me push this negative cosecant squared y to the right. So this is going to be dy over dx is equal to negative 1 over cosecant squared y. But what is cosecant squared y exactly? Now we know that, let me state that cosecant squared x negative, or how would I put it? Probably I will just write it like this. Cosecant squared x is equal to 1 positive cot squared x. Now why do I write this? Because the original formula is actually represented like this. Cosecant squared x negative cot squared x is equal to 1. So from here I can rewrite cosecant squared x is equal to 1 positive cot squared x. Now we know that cot y is equal to x. So what I would do is, I would be using these two formulas and I would be rewriting. So if I were to take this as 2, so these are all for your understanding. This has got nothing to do with the problem. Probably maybe I will just place this in red. So now, because of the understanding we have got, I can rewrite 2 as dy over dx is equal to negative 1 over 1 positive cot squared y.
Right. Now what do we have here? Okay, maybe I'll take this as 1. We got cot y is equal to x. So I'm going to rewrite this as negative 1 over 1 positive cot y raised to the power of 2, which is equal to negative 1 over 1 positive cot y is x, so this is going to be x squared. So now what have I got? I've got dy over dx is equal to, let me write that down, therefore dy over dx is equal to negative 1 over 1 positive x squared. So this is the solution. So students, let us obtain the derivative of cot inverse of 1 over x squared. Now we know that, I'm just stating the result which we just saw, d of cot inverse of x to be as negative 1 over 1 positive x squared. So I would be using this result. So this is equal to 1 over, of course there should be a negative sign, 1 positive. In place of x, I will be substituting 1 over x squared, but we got a degree to be 2, so I need to place that 2, times this has to carry a derivative of 1 over x squared, right? So that is very critical. So what I wish to do is, I would like to show you how this derivative is obtained. So let me use the space here. So this is going to be d of 1 over x squared. I can rewrite this as d of x to the power of negative 2. Now I can use this formula, d of x power n is equal to n times x raised to the power of n negative 1. So by this formula, this is going to be negative 2 times x raised to the power of negative 2 negative 1, which is negative 2 times x raised to the power of negative 3, which is negative 2 over x raised to the power of 3. So this is nothing but differentiating x raised to the power of negative 2. So I can fairly substitute that. Now foremost what I wish to do is, I would be simplifying this. It's going to be negative 1 over 1 positive 1 over x to the power of 4. Now I can place this differential, negative 2 over x to the power of 3, which is equal to negative positive 2 divided by, the LCM is x to the power of 4 positive 1 divided by x power 4. This is one term, followed by 1 over x to the power of 3. So when I flip it, this is going to be 2 times x to the power of 4 divided by x to the power of 3 times x power 4 positive 1. Now clearly x power 3 and x power 3 present in the numerator can be removed. That would give me 2 times x divided by x to the power of 4 positive 1, which is my solution to the question. So this is a good place for us to draw the red line. Students, we expected to differentiate x times tan cot inverse of x positive 1 over 2 times ln of x positive 1. So by linearity, I can rewrite this as d over dx of x times cot inverse of x positive 1 over 2 times d over dx of ln of x positive 1. Now this is similar to applying UV method, product rule, which is going to be u times v dash positive v times u dash. So that would mean differentiation of x times cot inverse of x is going to be x times differential of cot inverse of x. I told you already, it's negative 1 over 1 positive x squared positive cot inverse of x times differentiation of x is going to be 1. So this is one group, followed by positive 1 over 2. Differentiating ln of x positive 1 would give me 1 over x positive 1 times differential of x is going to be 1, differential of 1 is 0. So that's why I just got 1 there. Now I can rewrite this as negative x times 1 positive x squared positive cot inverse of x positive 1 over 2 times x positive 1. So this is the final solution. Probably if you want, you can perform some rearrangements if you want, but I feel that this is a good place to stop and ends the red line.
Students, this is the differential we are expected. This question is slightly different. Now I would be rewriting this as d over dx of x times cot inverse of x positive ln of, I'm going to write this as x squared positive 1 raised to the power of 1 over 2. Now we know that ln a raised to the power of b is equal to b times ln a. So using this formula, I'm going to rewrite this as d over dx of x times cot inverse of x positive 1 over 2 times ln of x squared positive 1. Now by linear property, I can write this as d over dx of x times cot inverse of x positive 1 over 2 times d over dx of ln of x squared positive 1. So differentiating this using product rule, I get x times negative 1 over 1 positive x squared positive cot inverse of x, differential of x is 1, so this is one group, positive 1 over 2 times differentiation of ln of x squared positive 1, that's going to give me 1 over x squared positive 1 times differentiation of x squared positive 1 would give me 2x. So clearly 2 can be cancelled. So this is going to be negative x over 1 positive x squared positive cot inverse of x and positive x over x squared positive 1. Now negative x over 1 positive x squared can be cancelled with positive x over 1 positive x squared, giving me cot inverse of x. So this is a good place to draw the line. Students, we are expected to differentiate this quantity x times root of 1 negative x squared divided by 3 positive sine inverse of x divided by 3. I can take the 3 out and rewrite this as 1 over 3 times, by linear property, I'm going to write this as d over dx of x times root of 1 negative x squared positive d over dx of sine inverse of x. Now this is UV formula, right? So this is equal to 1 over 3 times, so x times 1 over 2 times 1 negative x squared raised to the power of negative half times negative 2x followed by root of 1 negative x squared times differential of x is 1 positive 1 over differential of sine inverse of x is root of 1 negative x squared. So this is what we've got. So if we were to simplify this, so let me try to use the space. I know space is limited. So 2 and 2 can be cancelled. And then I can multiply x with x, that's going to be x squared. And then I got a negative sign there. And then I can bring this 1 negative x to the power of 2 raised to the power of negative half down. So that is going to give me root of 1 negative x squared. So I get a positive. Now if I were to take the LCM, so let me just take the LCM for these two alone, so that would give me root of 1 negative x squared. So this is going to be 1 negative x squared positive 1, right, if I were to take the LCM. So now I've got negative x squared over 1 negative root of 1 negative x squared, and I also am able to see a negative x squared over here. So I will try to perform a simplification. So I need some space, so I would use the space here over here. So I'm going to rewrite this as 1 over 3 times negative x squared divided by root of 1 negative x squared. This quantity, I'm going to rewrite it in this fashion, right? So followed by positive sign. So it's going to be 2 divided by root of 1 negative x squared, and then negative, so probably positive of negative x squared divided by root of 1 negative x squared. So I can write that.
So now negative x squared divided by denominator, negative x squared divided by the same denominator, you can add them. So you get 1 over 3 negative 2 times x squared positive 2 divided by root of 1 negative x squared. Right? So now what I wish to do is I would like to take the 2 out. So this is going to be 2 over 3 of 1 negative x squared divided by root of 1 negative x squared. Right? So all I did is just to take the 2 out. So negative x squared remains and positive 1 remains. Now I can rewrite this guy present in the numerator as this constant is retained. This is going to be root of 1 negative x squared times root of 1 negative x squared divided by root of 1 negative x squared. So clearly what we can do, these two things can be cancelled. So the outcome is, we will write the outcome here, negative 2 over 3 root of 1 negative x squared. So that's the solution. So this is the solution for this particular question. So I hope you followed the solution.
Welcome students, we are expected to solve this question. Problems of this nature keeps always occurring in examinations. So what we will do is we will use the u over v formula, which is nothing but v times u dash minus u times v dash divided by v squared. So this is called as the quotient rule. So this is rewritten as sin x negative cos x times differentiation of this quantity present in the numerator. Differentiation of sin x will give me cos x, differentiation of cos x will give me negative sin x followed by a negative sign, and then the numerator sin x positive cos x times differentiation of sin x gives me cos x, differentiation of cos x will give me negative sin x, so that's going to be positive sin x here. So this is divided by sin x negative cos x raised to the power of 2. Now we have to do some multiplication so that we would be able to simplify the outcome. Now if I were to take a negative sign out here, say I've got sin x negative cos x. So if I were to take a negative sign here, negative sign, so negative times cos x gives me negative cos x, negative times negative sin x would give me positive sin x. Okay, so I can do that. So this is going to be cos x negative sin x, and I have to place that negative sign. Now I already have cos x negative sin x followed by sin x positive cos x times cos x positive sin x. So this can be rewritten as sin x positive cos x raised to the power of 2 divided by sin x negative cos x raised to the power of 2. So this is negative, this is going to be cos x negative sin x raised to the power of 2, and I get sin x positive cos x raised to the power of 2 divided by sin x negative cos x raised to the power of 2. Now what we have to do is we will have to expand this one using a negative b raised to the power of 2 formula, which is a squared negative 2 times ab positive b squared, the other a positive b raised to the power of 2 formula, which is a squared positive 2ab positive b squared. I would be using a negative b raised to the power of 2 for this. I would be using a positive b raised to the power of 2 for this. So this is going to give me cos squared negative 2 times cos x sin x positive sin squared x negative sin squared x positive 2 times cos x sin x positive cos squared x
So this has to be divided by sin x negative cos x raised to the power of 2. Now cos squared x sin squared x is 1, followed by 2 times cos x sin x negative sin squared x cos squared x is 1, followed by 2 times cos x sin x. This has to be divided by sin x negative cos x raised to the power of 2. Now this is equal to negative 1 times positive will give me negative. In fact, it's negative times positive. Yes, it's going to be negative, followed by negative times negative. That's going to be positive, so it's going to be 2 times cos x sin x, followed by negative times 1. That's going to be, the outcome is going to be negative there. Excuse me. So negative times positive is going to give me negative 2 times cos x times sin x divided by the denominator. Now clearly what you can see here is positive 2 times cos x sin x can be cancelled with negative 2 times cos x sin x. You can add negative and negative. So that would give me a negative 2 divided by sin x negative cos x raised to the power of 2. So this is what I've got. Now if you want to expand this, you expand this, or if you want to stop here, you can stop here. So this is a good place for us to stop. Students, we are expected to differentiate 3 times x raised to the power of 4 or 5 x to the power of 5 negative 2 times x raised to the power of 4. Now you can either use the product rule or you can distribute the quantity like the way I'm going to do. So I would be doing so. So this is going to be written as d over dx of 3 times 5 is 15. I get x to the power of 4. That has to be multiplied with x raised to the power of 5. Negative 3 times 2 is 6. I get an x to the power of 4. That has to be multiplied with x raised to the power of 4. Now I'm going to use this formula in exponents. A raised to the power of m times a raised to the power of n is a raised to the power of m positive n. So by this can be rewritten as d over dx of 15 times x raised to the power of 4 positive 5 and negative 6 x raised to the power of 4 positive 4. So this is going to be d over dx of 15 times x raised to the power of 9 negative 6 times x raised to the power of 8, which is equal to, now by linear property I can rewrite this as 15 times d over dx of x raised to the power of 9 negative 6 times d over dx of x raised to the power of 8. Differentiating, I am using this formula. D of x raised to the power of n is n times x raised to the power of n minus 1. So by this formula, this can be rewritten as 15 times 9 times x raised to the power of 9 minus 1 negative 6 times 8 times x raised to the power of 8 negative 1. So 9 5s are 45, 4 9 1s are 9, add 4 you get 13. So 135 x raised to the power of 9 negative 1 is 8. 6 times 8 is 48. X raised to the power of 8 negative 1 is 7. However, you can take x raised to the power of 7 as a common factor and rewrite this as 135 times x negative 48. Okay, so if you think you can take some common quantity over here, you can do so, because I find 3 can also be taken out. So if I were to take 3 out, and this would be 3 4s are 12, 1 5 times x negative 3 1s are 3 1 6. So this works out very compact. So that is the solution to our question. So this is question number 90.
Since we are expected to obtain the differentiation for root of x times x raised to the power of 3 negative 8, so I would be rewriting this as d over dx of root of x times x to the power of 3 followed by negative root of x times 8. Now this can be further rewritten as d over dx of square root of x is going to be x raised to the power of 1 over 2 times x raised to the power of 3 negative, I'm going to just write it as x raised to the power of 1 over 2 times 8. Now by the law of indices, if you have got a raised to the power of m times a raised to the power of n, you can rewrite this as a raised to the power of m positive n. So by this you got x raised to the power of 1 over 2 times x raised to the power of 3. This is going to be x raised to the power of 1 over 2 positive 3, which is going to be 1. 2 times 3 is 6 divided by 2, which is x raised to the power of 7 over 2. So you can place 7 over 2 here. This is d over dx of x raised to the power of 7 over 2 negative 8 times x raised to the power of 1 over 2. Now by linear property I can rewrite this as d over dx of x raised to the power of 7 over 2 negative 8 times d over dx of x raised to the power of 1 over 2. So this is what you've got. So to differentiate I'm going to use d of x power n. So this is nothing but n times x raised to the power of n negative 1. That's a formula for differentiation. So this is going to give me 7 over 2 times x raised to the power of 7 over 2 negative 1 followed by negative 8 times 1 over 2 times x raised to the power of 1 over 2 negative 1. So I can rewrite this as 7 over 2 times x raised to the power of 7 over 2 minus 1. This is going to be 5 over 2. 2 divides 8 4 times. So it's going to be 4 times x raised to the power of 1 over 2 negative 1. That's negative 1 over 2. So this can be rewritten as 7 over 2 times x raised to the power of 5 over 2 negative 4 times. If I were to bring this guy down, this is going to be x raised to the power of 1 over 2. Now what you can do is you can rewrite this as 7 over 2. I'm going to write this as x power 5 raised to the power of 1 over 2 negative 4 over x raised to the power of 1 over 2. So this is going to be 7 over 2 times square root of x raised to the power of 5 because of half followed by negative 4 over root of x. So you can either stop here, or if you want you can take an LCM and you can simplify it. So if you want to do that, then I'm going to show you that. So if I were to take the LCM as square root of x, then probably I should also take 2 to be the LCM. So this one would give me 7 times, this is actually x raised to the power of 5 over 2. Now what you're doing is you got 5 over 2 and you are actually adding with 1 over 2, right? So this is x raised to the power of 5 over 2. So when you're product multiplying with x raised to the power of 1 over 2, you are having x raised to the power of 6 over 2, which is 3, right? So this is going to be x cubed followed by negative 2 times. This would lead you to 8. So if you were to simplify this, this is going to give you 7 times x cubed negative 8 divided by 2 times the root of x. So there isn't anything much you can do from here on. So I think this is a good place to draw the line, and we can move on to the next question. Students were expected to obtain the differentiation of square root of 1 negative x divided by 1 positive x. So foremost, what I wish to do is I would rewrite this as d over dx of 1 negative x divided by 1 positive x raised to the power of 1 over 2. Now this is one of the ways in which you can approach this question, but there are other ways also. What I wish to do is I would like to take this entire quantity as one term and perform the differentiation. So this is going to be 1 over 2 times of 1 negative x divided by 1 positive x raised to the power of 1 over 2 negative 1 times differentiation of 1 negative x divided by 1 positive x. So this can be rewritten as 1 over, now this is actually 1 over 2 negative 1, which is nothing but negative half, right? So which you can bring it to the denominator. So if you were to bring it to the denominator, this one will look like 1 divided by this entire quantity, 1 negative x divided by 1 positive x raised to the power of half. So this is what you've got. Times, you have to differentiate this. So I'm going to use u over v method. So d of u over v is equal to v times u dash minus u times v dash divided by v squared. So this is what you're going to use. So that's nothing but 1 positive x times differentiation of 1 is 0, differentiation of negative x is negative 1 followed by negative sign and 1 negative x, differentiation of 1 is 0, differentiation of x is 1. So this has to be divided by 1 positive x raised to the power of 2. So we need to have one more parenthesis. So this is equal to 1 over 2. Now 1 negative x, so let me just show that to you. So this is actually root of 1 negative x divided by root of 1 positive x times, this is going to be negative 1 negative x negative 1 positive x divided by 1 positive x, right, raised to the power of 2. Now negative x, positive x can be cancelled, so you get negative 1, that's negative 2. So I'm going to rewrite this as 1 over 2, that's fine. Now root of 1 negative x divided by root of 1 positive x, you can flip it. So if you flip it, this will go to the numerator. So 1 positive x divided by root of 1 negative x, right? So multiplied with negative 2 divided by 1 positive x raised to the power of 2. So this is what you're getting. Now I can cancel the positive 2 with the negative 2, and I can also look for any cancellations. Is it possible? Now what I can do is I can either stop here or I can do some rationalization. So let's see what we can do. Probably you can apply some simplification. So this is going to be negative. I'm going to rewrite root of 1 positive x as 1 positive x raised to the power of 1 over 2 divided by root of 1 negative x times 1 positive x raised to the power of 2. Now you can either push this to the numerator and simplify it, or bring this down to the denominator. So this is going to be negative 1 over, I'm not going to touch this, I'm just going to retain it as it is, root of 1 negative x. So I get 1 positive x raised to the power of 2. I'm bringing this guy down, so it's going to be 1 positive x raised to the power of negative 1 over 2. So I got a 2 and a negative 1 over 2, which means 4 negative 1 over 2, which is 3 over 2. So this is going to be negative 1 over root of 1 negative x times 1 positive x raised to the power of 3 over 2.
I can further rewrite this as negative 1 over root of 1 negative x times 1 positive x raised to the power of 3. This entire thing is raised to the power of 1 over 2. So this is equal to negative 1 divided by root of 1 negative x times square root of 1 positive x raised to the power of 3. So this is a good place to stop, and this is the question we started with. So the red line comes there. So we will move on to the next question. Students, the next question is we are expected to obtain the differentiation of cos x. Now differentiation of this is going to give you negative sine of cos x times you will have to differentiate this cos x. So that is going to give you negative sine of cos x times differentiation of cos x is going to give you negative sine x. Negative is positive, so the outcome is going to be positive sine x times sine of cos x. So this is the final answer. Now if in case you are asked to obtain the differentiation of sine x, then let's see what we are going to get. So differentiation of this quantity would give you cos of sine x times differentiation of sine x, which is cos of sine x. Differentiation of sine x is cos x. When you're rewriting it, you got to write it like this: cos x times cos of sine x. So this is the solution. Now several variations can be there, right? Say for example, question number 94, they are asking you to find d over dx of sine of tan x. What is that? This is going to be differentiation of sine is cos of tan x times differentiation of tan x, which is equal to cos of tan x times differentiation of tan x is secant squared x. So the solution is secant squared x times cos of tan x. So several variations can be obtained in this, so you will have to pay attention to that. Students were expected to obtain the differentiation of 1 negative e raised to the power of 2x divided by 1 positive e raised to the power of 2x. Now I'm going to use this formula. D of u over v is v times u dash minus u times v dash divided by v squared, the quotient rule. So by this quotient rule, I can rewrite this as 1 positive e raised to the power of 2x times differentiation of 1 is 0, differentiation of negative e raised to the power of 2x is e raised to the power of 2x times differentiation of 2x, that's going to give me 2. So that's fine, followed by a negative sign and 1 negative e raised to the power of 2x times differentiation of 1 is 0, differentiation of e raised to the power of 2x is e raised to the power of 2x, differentiation of 2x will give me 2. So this is what I've got. This has to be divided by 1 positive e raised to the power of 2x. This is raised to the power of 2. Now by distributive property, this is going to be negative 2 times e raised to the power of 2x. Negative times positive is negative, so I got 2 e raised to the power of 2x, and that has to be raised to the power of 2, followed by 2 times e raised to the power of 2x, negative positive 2 times e raised to the power of 2x, and that has to be raised to the power of 2. Now this is divided by 1 positive e raised to the power of 2x raised to the power of 2. Now clearly negative 2 times e raised to the power of 2x raised to the power of 2 can be cancelled with this 2 times e raised to the power of 2x raised to the power of 2, and these two can be added. So if I were to add these two things, I would get negative 4 times e raised to the power of 2x divided by 1 positive e raised to the power of 2x raised to the power of 2. So that is a good place to stop. We wouldn't be able to do anything much further in this apart from the fact of expanding this, which is of no vital use as far as this question is concerned. 1 positive ln x divided by x. So we'll be using the product rule. So this is going to be x times differentiation of 1 is 0, followed by differentiation of ln x is going to be 1 over x, followed by the numerator 1 positive ln x times differentiation of x, that's going to be 1, divided by the denominator raised to the power of 2. Now x and x can be cancelled, so that is equal to 1. Now if I were to remove the parenthesis, this is going to be negative 1 negative ln x divided by x squared. Positive 1 negative 1 can be cancelled, giving me negative ln x divided by x squared. So this is a good place for us to stop for this question. Now, just out of curiosity, if you are wondering what would happen if you are asked to differentiate x over 1 positive ln x. So let's see that. Now I will be applying u over v form. So this is going to be 1 positive ln x times differentiation of x is 1, negative x times differentiation of 1 is 0, differentiation of ln x is 1 over x. This has to be divided by 1 positive ln x raised to the power of 2. Now rewriting this, I would get 1 positive ln x, x over here can be cancelled, giving me negative 1, divided by 1 positive ln x raised to the power of 2. Now positive 1 negative 1 can be cancelled, giving me ln x divided by 1 positive ln x raised to the power of 2. So this is what we got when we have this question, and this is what we got when we add this question. So you can clearly see how different the outcomes are produced. So we will move on to the next question. Students, we are expected to differentiate ln of square root of x squared positive 1 divided by x squared negative 1. I'm going to be rewriting this as d over dx of ln of x squared negative 1 divided by, in fact, x squared positive 1 divided by x squared negative 1. This has to be raised to the power of 1 over 2. Now we know that log of a raised to the power of b is b times ln a, or log a. So this can be rewritten as d over dx of 1 over 2 times ln of x squared positive 1 divided by x squared negative 1. Now we have a formula, ln of a over b is equal to ln a negative ln b. So by this formula, this is equal to 1 over 2 times, I'm taking the constant out, d over dx of ln of x squared positive 1 negative ln of x squared negative 1. So this is what we have got. Now I'm going to differentiate this. So for differentiation, I'm going to use first the linear property of the function. So that would be d over dx of ln of x squared positive 1 negative d over dx of ln of x squared negative 1. So this is what I've got. Now what I'm going to do is I'm going to start the differentiation. So differentiation of ln of x squared positive 1 is 1 over x squared positive 1 times differentiation of x squared, that's 2x, differentiation of 1 is 0, followed by, this is going to be 1 over x squared negative 1 times differentiation of x squared is 2x, differentiation of negative 1 is 0. So this is what I have got. So now this is equal to, if I were to bring the 1 over 2 inside, I would get x, because 2 and 2 can be cancelled, so this is going to be x over x squared positive 1 negative x over x squared negative 1. So don't cancel them out because the denominators are totally different. So what I'm going to do, I'm going to take the LCM x squared positive 1 times x squared negative 1. So this would give me x of x squared negative 1 followed by a negative x and x squared positive 1. So if I were to rewrite this, this is going to be equal to x cubed negative x cubed negative x divided by, this is going to be x to the power of 4 negative 1. So clearly positive x cubed negative x cubed can be cancelled, these two can be added, so that is going to give me negative 2 times x divided by x to the power of 4 negative 1. And we got that result. Let me underline it because of the question. Right, so this is a nice spot to stop. Students were expected to differentiate tan inverse of 3x squared positive 2, and we will be using this formula. D over dx of tan inverse of x is 1 over 1 positive x squared. So by this formula, this is going to be 1 over 1 positive 3 times x squared positive 2, it's x squared, so raised to the power of 2 times differentiation of 3x squared positive 2. So this is going to give me 6x, differentiation of 2 is 0, divided by 1 positive 3x squared positive 2 raised to the power of 2. If you want, you can expand this and write this as 1 positive, I'm using a positive b raised to the power of 2, which is a squared positive 2ab positive b squared. So by this formula, this is going to be 3x squared raised to the power of 2 positive 2 times 3x squared times 2 positive 2 squared. So this is equal to 6x divided by 1 positive. Square of this is 9 x to the power of 4 positive 2 times 3x squared. So that's going to be 6, or 2 times 2 is 4, 4 times 3 is 12. So this is going to be 12x squared positive 2 squared is 4. So this is what you've got. You can probably add 4 with 1 and you get 6x over 4 with 1 would give me 5. So I will start by writing 9x to the power of 4 and then 12x squared and then 5. So this is my final solution for the question. Students were expected to differentiate cot 5x, and that is raised to the power of 5. So this is going to be equal to, if I were to start the differentiation, it's going to be 5 times of cot 5x, that's raised to the power of 5 negative 1, times differentiation of cot x. Right, so differentiation of cot 5x would have to be present, followed by differentiation of 5x. So this is the complete solution. So I can rewrite that as 5 times cot of 5x raised to the power of 4. Differentiation of cot x is negative cosecant squared 5x. Differentiation of 5x is 5. So if I were to rewrite this, this is going to be 5 times cot 4 of 5x with a negative sign. Of course, there is another 5 here. Probably I can say 5 squared, and then This is cosecant squared 5x. So that is a good place to stop for this question. Students, we are expected to differentiate 1 positive x positive 1 divided by x squared. This is in the numerator 1 over x positive 1. So foremost, what I will do some simplification. So d over dx of, I take the denominator as x. This is going to be 1 positive x. Already I got a x squared over here. So if you were to flip that, so that would occur here. So this can be rewritten as d over dx of 1 positive x divided by x to the power of 3. Now I will be using u over v formula, which is v times u dash minus u times v dash divided by v squared. So by this formula, this is going to be x to the power of 3 times differentiation of 1 is 0, differentiation of x is 1, negative 1 positive x times differentiation of x cubed is 3x squared divided by x to the power of 3 raised to the power of 2. This is going to be x cubed, 3x squared negative, of course the negative sign follows, so this is going to be negative 3 times x squared. This is 3x cubed with a negative sign, and that has to be divided by x to the power of 3 times 2 is 6. Now these two can be added, so let me write that down here. If these two can be added, this would give me negative 2 times x cubed, negative 3 times x squared divided by x to the power of 6. If I were to take negative x squared out, then I would have a 3, because 3 times negative x squared would give me negative x squared, and then followed by a positive 2 times x. 2 times x times x squared will give me 2x cubed with a negative sign divided by x to the power of 6, which can be rewritten. These two can be cancelled. Of course, you have a degree 4 there. So it's going to be negative, I'm going to rewrite it as 3 positive 2x divided by x to the power of 4. So this is a good place for us to stop. So we'll do one more question, students. We're expected to differentiate e raised to the power of x over 1 positive x cubed. Now clearly the differentiation of this is going to be e raised to the power of x over 1 positive x cubed. That's fine, because when you differentiate e raised to the power of x, you get e raised to the power of x times differentiation of x. So that is exactly what we should do. So times differentiation of x over 1 positive x cubed. So this can be rewritten as e raised to the power of x over 1 positive x cubed times, this is u over v form. So I will start off with 1 positive x cubed times differentiation of x is 1 followed by a negative sign, and x times differentiation of 1 is 0, differentiation of x cubed is 3 times x squared divided by 1 positive x cubed raised to the power of 2. If you are wondering what formula we used in this case, it's nothing but d of u over v, which is v times u dash minus u times v dash divided by v squared. So this is what we have got. So using this and performing some simplification, this is equal to e raised to the power of x over 1 positive x cubed times, and want to distribute the quantity, so it's going to be 1 positive x cubed negative 3 times x power 3 divided by 1 positive x cubed raised to the power of 2. So this is equal to e raised to the power of x over 1 positive x cubed, that's there. X cubed with 3x cubed with a negative sign will give us negative 2 times x cubed followed by a positive sign and divided by 1 positive x cubed raised to the power of 2. So this is a good place for us to stop. Students, thank you so much and enjoy your day.